Good morning. Um, Welcome, everyone. My name is Panos Zarogiannis. I'm the team leader for the Drinking Water Directive team at ECHA, and I will be your chair for today's workshop, the second day of this demonstration workshop. Thank you for joining us today. Um, we can move to the next slide. And the next slide. Workshop, the second day of this demonstration workshop. And the next slide. There are too many introductory slides, but thank you. As mentioned yesterday, the event is being live streamed, and you can watch it either from the event page or from YouTube. There are two live streams. Don't be confused about that. There was one for day one. There is another one for day two. And these streams are hosted on YouTube, so if you want to go back later and watch them again to follow something more closely and to listen again to something that perhaps it was not clear the first time, you can go back to YouTube. We went through several Slido questions yesterday, and we will continue to use Slido today. There's a Slido widget on the event page. There is also the QR code you can see on your screen. Perhaps you can scan it with your mobile phone, and through this you can ask any questions, which we will try to take later today. As we have requested already since yesterday, we would like to focus on questions primarily focused on Euclid. This event is specifically dedicated to Euclid, and we would prefer to avoid, if possible, questions that fall outside this scope. There will be two separate Q&A questions and answer sessions for today. One will be before our lunch break, another one will be at the end of the day. Ideally, the first Q&A session will cover the presentations that we are making in the morning, while the second Q&A session will cover questions relevant to the afternoon's presentations and demonstrations, plus any other open issue. Next slide, please. Now, what did we do yesterday as a recap, especially for those who may have not been able to follow yesterday the event? We covered general aspects of Euclid and how it is used in applications for the Drinking Water Directive, and we touched upon the new Euclid Drinking Water Directive application manual. Yesterday's practical demonstrations included the dossier header, substance identity in section 1 of Euclid, intended uses in section 4, and the electrochemical testing for passive metallic compositions in sections 5.2. Again, you can watch these presentations through the YouTube streams. The next slide, please. To finish with my very short introduction, today what we were going to do, we will be demonstrating how to prepare section 5.1 on the migration of potentially relevant chemical species and the identification of relevant chemical species, section 6 on analytical methods, section 7 on toxicological data, and section 8 on risk acceptance. We will also cover additional important aspects of Euclid, such as the validation rules, the dissemination preview, and the timelines for the two processes, notification of intention and application, and other practical considerations. So let's get started. Thank you for being here. There will be a presentation section 5.1 now, and please do submit your questions through Slido, and we will take them as soon as we can. Thank you. So let's get started. Thank you for being here. There will be a presentation section 5.1 now, and please do submit your questions.
Hello and good morning. As said, in this following section of the workshop, we will talk about how to fill in the migration of relevant chemical species in Euclid. Hello and good morning. It's a section 5.1, as mentioned, and there is a slot of about 1.5 hours reserved for this. Hopefully we'll get to cover as much of the details as we can. The idea is that I will first explain in a few slides some key elements of the migration study record, and then later on I will demonstrate for two material types, for organic and metallic materials, just how they should be filled or what is there in the current format, to give some information on that. And we have chosen to do this because although they are migration studies, there are some key differences between the different materials because of the standards or the guidelines, which are the legal requirements in how to do the studies. So first, I will move on to some key concepts. A migration, of course, is very important in drinking water applications for the positive list. It is one of the key information that is needed besides toxicological information, and it will be used to determine whether or not something will be acceptable on the list or not. So it is really the main test to provide information on the safety of a substance or composition by exposure. So the migration actually here would determine the external dosage of oral exposure that you're going to have, and that's why this is really important. Migration together with the conversion factor or the A factor from the intended uses, as discussed yesterday, will determine what is the CTAP value that is then compared in the risk acceptance. So it really is used there, and it is really important. Also, the amount of migration will determine the amount of toxicological information that is required when setting MTC taps for different substances that migrate, which do not already have an MTC tap before. And just to note that migration test or migration information, it cannot be omitted. It always has to be there in one way or another. It can be adapted to some extent. The experimental migration test for all materials, that would be mostly the main option that is needed. And this is actually the things that will be demonstrated later in this workshop. In some cases, according to the legal text, there is a possibility to do modeling or full transfer calculation for organic materials and a scientific dossier for metallic materials, but these will be covered maybe in future workshops. These are something which are using the same study record, but they will be also using these dynamic content rules in Euclid. So when you are filling in experimental test, you will not see any information related to the modeling. Then moving on, just briefly, where to find this in Euclid. In Euclid, the section 5.1 is right there on the section 5 of the table of contents for the drinking water application. And it's above the passive compositions electrochemical test of 5.2. And the fields that are actually shown in the migration study record, they reflect the legal requirements in Annex 4 of 365 decision, which of course only refers to the testing guidelines. So basically what we have in the Euclid study record is the information that is required by the testing standards. So that's where they are actually coming from. So we are not really requesting anything other than that what would be in the testing guidelines if those are followed. Then how many migration records are needed? This is a question we have been asked before in the past. And as with the intended uses, there will always have to be at least one, and sometimes that one is enough, like for metallic materials. The migration study records that you fill in with the application, they should also match with intended uses. So if there is an intended use declared, then there should be a migration study corresponding with that use. So for some cases, like for organic starting substance, if you use it in plastics and rubbers, maybe you need to declare 2 intended uses, but also 2 migration studies in this case. And as said yesterday, each migration test should reflect the worst case use. And this means to say the conditions which result in the highest concentration in water, so that the testing that you're doing should be conservative. And if this is done, then anything which is less risky could be accepted based on the one test. This is actually also something that is a legal requirement in the Annex 4. Also, each migration test piece should reflect worst case material. We have some guidance in ECHA Guidance Volume 1, what this actually means in practice. For metallic materials, it means that you have to have specific compositions where migration would be, or metal release would be maximized, and also concerning organic materials. This is the same case reflecting to the concentration of a substance in a material, but also the structure of the material. Then about the migration and the different material types. So as said, the information requirements really depend on the kind of testing standard that is legally required. There are quite a bit of similarities for organic materials, cementitious materials, and enamel, ceramic, and inorganic materials. In fact, when you're testing organic materials and enamels and ceramic materials, the testing standard that is legally required is actually the same. It is the static test, the EN 128731. And for cementitious, it's a different standard, although it's also a static test. And that's why the requirements there, also how the test is conducted, is largely similar, with some differences in test water, for example. For metallic materials, the standard legally required is the EN 156641. And this is a dynamic test, a rig test, where water is flown through a piping system with repeating flow and static periods, and it's simulating a piping system a little bit. So this is very different from the static tests, and that's why there are some big differences in how the results are presented, how the testing is described, and so on. So really, for organic, cementitious, and enamels and inorganic materials, what you have to fill into EUCLID, how the tests are run, they are very similar to each other, while for metallic materials, when you follow the legally required standard, it's very different. So this is why also in the demonstration phase, I will show you organic and metallic, because these cover most of the things that you have to fill in or should cover. Then about the structure of this migration study record. Again, it's very similar to the general structure that most EUCLID study records of this nature have. Just to remind you that this migration study record, it has been created specifically for Drinking Water Directive. So it's a new thing. And of course, when you design new things, there are bound to be some things which don't work the way you wanted them initially. And that's why also any feedback we will get is good, because this will help us to improve further still the current versions. So in the migration study record, at the very top, there's the section called administrative data, as with some other records as well. Then there is, importantly, the data source. Then there's materials and methods, where you have to describe test piece, test guideline, study design, test waters. Also, there is a section called results and discussion, where the main results or the key results should be inserted. And of course, there's a section for attachments for any things that you want to disclose with us, to explain certain things. And finally, there's applicant summary and conclusion. And some of these things here, like data source, test fees, test guideline, results and discussion, I have highlighted those in red color and bold, because these are really some of the very important things that have to be filled all the time. But also, it is very likely that we will have automatic rules to remind you that you have to fill this in or you cannot submit. Okay, now, as I mentioned, this general layout of the structure of the study record, I will go into details of those things that I have highlighted here in red. So key information, number one, the data source. So this is the same kind of data entity in EUCLID that was used for the passive metallic materials electrochemical study. This is the place where you should insert the full study report from the migration study. Using this data source and giving out the details and practical details. For example, here you can see that there's the reference type, study report, title, who's the author, year. Then there's the attachment, the document actually, which should be attached here, and then some other practical details. But I will also demonstrate this in the actual how it works and looks like in EUCLID, although I did that also yesterday, but repetition is the key to learning. So, and hopefully this is also good, because we we are aiming to use the functionalities of Euclid in this as much harmonized way as we can. So that's why this same data entity used in many places in Euclid to really store these main reports that are coming from different studies. Then another piece of key information is description of the test piece. There are some specific legal requirements about this. And how test pieces are described, of course, they vary depending on material type. Of course, you would need different information to describe organic materials than metallic materials. But some things which must always be there legally required are production details. So specifically name of producer, production date, and this is especially important for cementitious materials. We have in our guidance actually the age that the test piece for cementitious materials should have before doing the test. And this is, of course, because cementitious materials by nature, they start reacting when they start to set and harden, hydrating. And then if it's too young or too old, it won't be any more similar to a specific time window. So it's really important that the cementitious test piece is of a certain age before testing. Also, the production details or the processing steps of the test piece should be given, should reflect the intended uses, of course. Some physical characteristics are needed, of course, and formulation or composition, and also for organic and cementitious materials, dosage and or concentration. And just to shortly remind the actual legal text, so here you can see on the left the test piece is mentioned in 5.1, and in this 5.1.1 there is this phrase, detailed description of the test pieces, including dimensions, production, storage, sampling, and name of the producer of test pieces. So this text here also, of course, it means that it has to, the description of the test pieces has to be detailed, and it has to include these certain things mentioned, but also it is not limited to those. So really, we are needing some details for the test pieces. Then specifically for the starting substances or organic cementitious constituents, dosage is mentioned, so this is really required. And also there's a mention of a concentration, so this should be provided as well. And then again, for the inorganic materials and metallic materials, what is needed is really the composition of the test pieces. And this, of course, can be routinely analyzed. Also, specifically for metallic materials, there's a requirement to provide roughness of the inner surface of the test pieces. And at the moment, we are actually discussing internally what would be the roughness value that we will use and how that would affect the evaluation. But it should be provided anyway. Then just another piece of key information concerning the test piece. As mentioned previously, it is important to provide the date of production of the test pieces. And unfortunately, at the moment, there is no dedicated field in Euclid for this. There will be in the future, of course, but at the moment, you should provide this information in this field called any other information, which is here in the red box. So this is an open text field where you can provide any information you want. But one key thing that should always be there is the date of production of test pieces, because this is very important and the most important for the cementitious materials, for sure. Let's see, then moving on. So key information, the test guidelines. So this is actually a similar thing that I was showing yesterday. So again, repetition, it's hopefully making it easier. So you always should provide similar kind of information for all the migration tests. So what you have to always provide is a test guideline and ISO 17025 or other quality assurance You should indicate these both. And also about the quality, you have to provide some kind of documentation. So in most cases, hopefully, what the applicants will do is they will use the legally required standards. They should be the starting point. Surely for evaluation purposes, it is a point of reference against which everything is evaluated. So for example, here for organic materials, in the best case, the one it is easier for everybody, you follow this standard EN 1287731 for factory-made products and the version 2 for site applied. And you follow this according to guideline, as said here, and you use the latest version, you don't deviate. And additionally, the migration test has been conducted by a laboratory who has an accreditation for doing this particular standard migration testing according to ISO 17025. And also that there would be the accreditation certificate and the annexes attached. And of course, we need these accreditation certificates and annexes to demonstrate that the scope of the accreditation is really the good one. Because if some laboratories accredited to do under ISO 17025 to do, let's say, hardness testing or tensile strength testing, it doesn't mean that they can do migration testing with the same quality. So this is why we would need some documentation. How exactly is this quality met? And the easiest way to do this is to use accredited laboratories with the accreditation certificates, of course. So this has to be always provided. Then about the results. So there is a section called results and discussion, and the main results from the migration test should be provided in the Euclid fields. And these main results, of course, they should originate from the test report provided by the laboratory conducting the test. For organics, cementitious, enamels, and so on, the main results would include the concentration that is measured from the migration test water, then the migration rate, which can be calculated based on the test and the test geometry used, and then the CTAP for the third period of migration for cold water, or seventh period if we're doing testing in warm or hot water. And the CTAP, of course, is calculated here using the migration rate and the conversion factor for organic, cementitious, or enamels and so on materials. Then in contrast, for metallics, what you would need is the average concentration values from the test report again, and the calculated CTAP using the A factor this time for these 3 weeks, 16, 21, and 26, for all the metallic elements which you have to analyze in your migration water, as stipulated by the legal text, and also in all test waters that you are using. If you follow the legally required standard, there can be up to 3 test waters. When you're adding an alloy to an existing category, you need to test only with 1 water. If you are creating a new category, you have to test with 3 test waters. So the number of values that you need to provide can be anything from 3 to 30 or so. But as I demonstrate how Euclid is functioning at the moment, I hope this is not too tedious to fill in Euclid all these concentrations. And then this is just to show how these different materials in Euclid appear. So I will, of course, demonstrate this more in detail, but you can see here on the top, there's a repeatable block which is used to insert data for the migration results, the main results for organic, cementitious, and enamels, and ceramic and inorganic materials. And then for metallic materials, there is this repeatable table where you can insert the results for different time periods, different reference substances, different waters as a table format. So that should be relatively easy to fill in. And of course, I will show both of these in Euclid in practice, how they actually work. Okay, it seems I have now come to the end of the actual presentation of the slides, and now I will go into live demonstration. It seems we have about 1 hour at least reserved for this, so I'm sure we can go through all of it. I will just try to switch now to switch the screens. No. Bear with me. I will try to. Okay, there we go. So what I have here open is, of course, the Euclid. And this is now the dossier I was using yesterday for intended uses to demonstrate the organics. This time around, I will go to this section 5, which is the migration of the substance, electrochemical tests. And there is a study record I have created. I've named it vinyl chloride in PVC, just to give a title that is a little bit indicative of what it's about. And then starting from the top, there is this one key field that you must always fill in. You cannot submit or do anything without filling this, the material type. And again, of course, you use this to select the your material type and of course the European positive list that you are really going to apply on. And this is also in this study record of migration. Selecting the material type will use the dynamic content rules so that when you choose your material type, it will then determine which fields you will be seeing later on when using and when filling your data set. So it'll make your life easier as well because you don't see all the fields. But here I've chosen the organic materials, as said. There's also a field for any remarks, but here I'm not going to use that. I don't need it. The first section here is the same as for the electrochemical test, the administrative data. This is just some practical information. One important field here is the type of migration information. So this is the field where you can use a pick list to choose between the different options. You can see here I have the experimental study selected, but also if you would be submitting something with modeling, then you should indicate here that it's modeling the diffusion-based or modeling full transfer calculation. You can also see that there's the option for a scientific dossier, but it's grayed out. And this is because I'm now I have selected organic materials as my material type. And for organic materials, only these 3 options are available. Later on, for metallic materials, when I will do the same thing, you will see that the modeling options are grayed out and the scientific dossier is available. So this is also to help you not to choose the wrong things by mistake. But here now, because we are focusing on the experimental study in this demonstration, I will click on this. That was the thing that I chose. Then here you can indicate the study period, the start date, end date. They should be in the report that you get. And then again, as for the electrochemical test, you can indicate the reliability, give your estimation. And if you follow guideline, don't deviate, and everything is good, then it should be 1. And there is, again, this question mark, which you can click to open a help text to remind you what the different categories of reliability mean. So 1, 2, and 3, which are the choices that you have. And then here, actually, you can see here there are 2 fields, justification for migration data adaptation and attached justification. These are some things that probably won't be in the future versions for experimental studies. So if you do an experimental study, you don't need to, of course, justify why you're doing it. It's the basic thing that you do. In case you're going to be doing modeling, then you would have to justify why you do modeling instead of experimental study, and there are some legal criteria when you should be using it. But these fields don't have to be filled right now here. Then again, we can move on to data source. So this is the place now where you need to attach your migration study report coming from the laboratory who's doing the test. And you can use this data source, data entity to give it. So there's this field reference. Here you can click this and you can add a literature reference or a study report of any kind. So basically, you just give the details, and here you select from the different options that you have, you select study report, and then you can fill in all the practical details in the fields, which are here below. So like the title of the report, this is a mandatory field shown by the asterisk here, the little red dot. So you have to fill in a title. Then who's the author, what year, what was the testing facility, bibliographic source, not necessarily for the migration study report. Then the date again here when the report was issued, so not the test, but the report. If there are any numbers from the laboratory or whichever entity that is issuing the report, the sponsor of the study, so who's financing it, and if there is study numbers, then you can also insert that here. But most importantly, what you need to do is attach a full study report into this field, and you can use different formats. PDF is good, mostly, and then just describe your attachment type. And here, actually, you should always attach this to this attached sanitized document for publication. So just a disclaimer that we will publish the applications. So you should always only provide us with reports which are sanitized for publication. Okay, I hope that is clear. I will close this now. I don't need to save anything. Then, of course, in the same data source field, you can give indications who is owning the data and if there's any disclaimers made. Then we move on to this materials and methods section where you should describe the test piece, test guidelines, study design, and so on. And this is the bit that may require some scientific or technical knowledge on what all these fields mean. Basically, what we are asking for is just some information to describe the material type along with the substance, because it is from the material that the substances are migrating or not. So this is why it's really important. Here, for example, the easy things here, you just choose the organic material category first, so plastics and polymers. This thing that I'm showing here now, it should actually match with the intended uses for the use of vinyl chloride to produce PVC. So that's why plastics and polymers, and also in organic material subcategory, again, I've chosen the PVC hard. Just quickly show what is also in intended uses. So the same kind of pick list to choose your material subcategory. And if you don't find it here, you can always use these other fields. So this should be easy. You should know this. And then production of the test pieces. It was a legal requirement to give the name of the test piece producer, but also this is now one of the fields in this study record that are confidential by nature. So this is not to be published anywhere, but you still have to give it to us. Then about the organic material type, as said, you have to describe the processing of the material. So monomer polymerized by addition, then it's a thermoplastic resin. The fabrication method of your actual product. In this case, we were talking about extrusion yesterday. And also in remarks here, we've added this temperature range, roughly where it should be produced. Just to say that these are actually something where you have pick lists. So the main polymerization types, addition, condensation, and other, in case there's some other variation that you're using, you want to describe. Then the resin type, and of course there's two options, thermoplastic, thermosetting. And the fabrication method, again, can be chosen from a pick list. So there are all these different basic production ways, and also the other in case you use something else. But these are just basically to describe what kind of material you're using to test and how likely it would be. Then in evaluation, it helps to evaluate how much there would be things that would probably migrate. Here is also this field called additional processing steps, if relevant. So if you need, you can always describe some additional information here. If you look at the question mark, it will give you some tips, describe relevant additional processing steps, such as vulcanization, reinforcement. This can be relevant for some particular materials like rubbers and so on. Not for everybody and not for everything. Then after describing these, there is a field where you can insert the repeat unit composition of main polymer. This is basic for vinyl chlorides, of course, this kind of thing. Then molecular weight of the matrix, the amount of crystallinity. In this case, it seems we have 5%, so mostly the PVC is amorphous. Viscosity, then density, which is an indicator of how dense the material is. The worst case will be the least dense material that you can have. Polarity, this of course also may affect migration, and then tacticity, which is following from whatever is the process that you use to create the polymer. And this is just I will try to demonstrate. So this is, of course, you can choose from a pick list, polar, non-polar, and tacticity. Again, what you'll have here is just 3 options in a pick list. So the basic tacticities that you can have. Then you can also describe the presence of copolymers or the lack of those. So in this case, for example, there's no copolymers. It's just unplasticized PVC. But you should describe whatever is your case. If you have copolymers, then that's good to describe here. Then there's a field where you can add a picture of your molecular structure. Then just to finalize for the description of the test piece, the chemical description of it, the degree of cross-linking should be indicated here. In this case, we have no cross-linking. Then these are the 2 legal requirements that were specifically mentioned in the legal text. So you should always provide us the dosage of the applied for starting substance to produce the test species. And also there's a field for the concentration of the applied for starting substance in the test species. So the dosage and the concentration, this could be mostly be equal, or at least the dosage should be slightly higher than the concentration, of course. And then finally, you can give the basic formulation of your test species. And you can do this by using the reference substance entity to indicate the substances. So by clicking this, it's the same reference substance entity that is used in many places in Euclid, like substance identity and yesterday in the electrochemical test. So this is just to describe different substances that are in the mix here. Also, you can indicate the type or the technical functionality that this particular substance is playing in that test piece. So additive and a lubricant. And also you can indicate an average concentration. I must say that this field at the moment, the concentration, it is a numerical field. So what you should give is the average concentration. Later on, I think we will change this to range. So you can give ranges instead of absolute values. So this is an average at the moment. So you should use it like that. So, and here you see I've just added these different components, 3 additives and the main polymer, and then the concentrations. And if I would need to add a new substance here, I would just click on the new item. I would go to chemical name. If I would have something already in my reference substance library, I could just choose from the list, or I could go here and create a new one by just indicating the name and some details that I know. So let's say I want to add, I have citric acid for some reason in my PVC. This is used in cementitious materials often, but I'm not sure about PVC, but just for the sake of adding it. So I add here. Also now Euclid will be telling me that because I gave this substance, I need to also indicate the type. So here I need to tell whether it's an additive, A2 polymerization, monomer, or polymer fractionate, or something else. Let's stick with the additives here. And then I can choose technical function from a list. Let's say we use this as an anti-static agent. Not sure, probably not used in that way, but yeah, still. And then we can add some kind of concentration value for it. So it's quite simple, because if you have the formulation in front of you, you should be able to fill this in relatively simply. Finally, there's a field called analytical data of test piece composition. And here, if you click a question mark showing the help text, it says, add here a link to the relevant analytical methods document. So this is actually a link to a document in Euclid in section 6, specifically this one, the test piece composition. And you should provide here all the details of the analytical method used to analyze the test piece. So it's not the results themselves, but just what method was used and how reliable that is, and so on. Because all the analytical information concerning migration, they should be stored in section 6 of Euclid. And these links will help us to navigate then these different sections. Then any other information. This is a free text field where you can give any other information. As said, one important thing that we would like you to always give here for now is the date of production of test pieces, as I've written here in the very top. And then the other information is optional. So you can just give whatever kind of information you think is needed here besides what you've already given. Okay, I think now we've covered the so-called chemical characterization of the test pieces. And then also, besides the chemical characterization, you need to have some physical characteristics of the test piece as well. Like starting from the shape. So here the test piece was a pipe, and you can also choose whatever shape you use in the migration test, like pipe segment, plates, or taps, or whatever. You can choose from a pick list. There are a few options here, and also the other, so you can always describe what was used to test. It can be also the product if that was the case. But for example, pipes can be used, just fill the pipe and do the test. Then after choosing the shape, there's a field, this is a free text field, where you can describe the physical dimensions of the test piece, including wall thickness of pipe and thickness of plate sample. So here it's written just something simple like this. So pipe shape PVCU with 32 millimeters outside diameter and 2 millimeters wall thickness. And just some basic descriptors for the physical shape. Then below that, there's a field called layering. So there's a pick list to select whether your sample is single layer material, whether it's multiple layer in case you have this. And also, in case you have something that you test that has multiple layers, you should also describe which layers there are and also their sequence, and indicate which layer is actually the one that is the contact layer and where your substance is. For the purposes of applying for the European positive lists, we would hope or expect that mostly you should test single layers containing your substance for the most cases. But if this is somehow impossible, then of course you need to do the multiple layer material, the real material more. And as said here, really a pick list where you can choose either one. And then there's this field called thickness in micrometers. And from the help text, this is really meant to indicate the thickness of a surface layer when relevant. So if you're applying for something that is used in a coating, then how much is the coating film thickness should be indicated here. And then after these physical characteristics, there's also some fields to describe the storage of the test piece. So storage of the test piece, you can just indicate how the test pieces were stored before the test, in what kind of conditions, and also the treatment, if there was any treatment before the actual testing, like surface purification or something like this. And these are free text fields, so you can just type in some information. And these, again, all the things that I described so far, they should originate from the test report. So then after describing the test piece, we move on to test guideline. This is the same as for the passivating or the electrochemical testing I was showing yesterday. So there's this section called test guideline, where you can add, by clicking on this new item, you can add a row. I've added here one row. I will delete this here. We can always delete things from this trash can icon. You can also clone by pressing this functionality here. So you can easily duplicate and get rid of unnecessary rows that you don't need. So here I've chosen now, I filled in this field. So I've added one row indicating the test guideline. This is very important. You need to always indicate this. And also according to guideline and the version and no deviation. So I could just, for demonstration, add one line here. So basically, if you click on this field, you see that the selection of a guideline is a pick list again. So you have only a few options. For organic materials, you don't have any other options than these two actually legally required standards. Then there's also the modeling specifications that you can choose if you do modeling, but all the others are grayed out. Then there's the option of other. So in case there was some way that you would just think that you really cannot use these legally required standards, you have to do something else, then you choose other. But then you have to explain to us later on, why did you deviate? Why did you not do the legally required standard? Also, there's the field called qualifier, where you can indicate whether you did according to guideline or no guideline available or something like this. And for the version remarks, you can just type in with the numbers there. And deviations, this is again a pick list, just yes, no, or not applicable, not specified. So hopefully this is mostly no, that you do not deviate. Also, mostly we hope that for organic materials, you would always use this EN1 to 8731. Then after choosing this test guideline, oh yes, so as mentioned, if you would do something else than the standards that we are legally requiring, you need to really describe the method here. There's a field for that, principles of method, if other than guideline. But when you, of course, follow this guideline, you don't have to explain it anymore because it's publicly available, the standard method. After this part, after describing the guideline, similarly to what was for the electrochemical test, you need to describe the quality assurance. So basically, there's a field where you can choose from a pick list, either the ISO 17025, which should be the case mostly, or other, in case there is some reason that some other quality assurance, which should be equal to this one, was followed. And as said, you need to also indicate some documentation how this quality was required. And the easiest way to do this is to use a laboratory which has an accreditation for the relevant standards and methods that you are using. And here it's just written here, so in the remarks, so you can write something like accredited laboratories, see attachments for certificates, so that we can see that it should be there. We will look for it anyways, but still. Now then, after this section, there is some fields about the study design. This is basic information, again, that really should come from the full test report. So you should have the information if you have the test report. You just indicate the number of test pieces here, then the test temperature, cold. This is again something where you can choose from a pick list, cold, warm, or hot. And This again, if you're thinking about the worst foreseeable test conditions, of course, it could be indicated that generally speaking, I guess hot water and warm water are worse than cold. Here is a field where you can describe the total number of migration periods because the evaluation or the CTAP that is used in the evaluation and risk acceptance will be the third period. For cold water, you should have at least a minimum number of 3 periods. Migration period length, again, according to standard for cold water tests, this is 3 days or 72 hours. For hot water, it's 24 hours. Surface of contact coming from the geometry of the test, volume of water in contact in liters, and then the surface to volume ratio. This is, of course, very important parameter in the test. And if you follow the standard guideline, this is actually, there's a range of surface to volume ratios that should be used. Then there is also this free text field where you can describe the test procedure, briefly summarize what was actually done. This should be also in the full study report that you should provide to us. Then also for organic materials and cementitious, there is a field, was a screening analysis conducted? This should be mostly yes, because you have to do this to analyze the NIAS. And then there is a link, again, results of analysis of testing waters by a screening method. And if you click on the question mark to see the help text, this will tell you that you can provide links to relevant screening studies. So here, if you do one or more screening studies or non-targeted analysis, this is the place where you need to provide a link again to the analytical methods section or the section 6, where the details of the non-targeted screening method should be provided. Okay, after study design, there is a placeholder where you can insert test waters or the basic information about the test waters used in the test using repeatable blocks. And in these repeatable blocks, you have these fields. So water type, this is something you can choose from a pick list, either according to standards, what they stipulate about test waters or other. Then also there is a free text field where you can describe a little bit the test water preparation. Then the chlorine content. So in this case, of course, this was, for example, a test water according to EN 128751, 128731. And the normal case is there is no chlorine. There's a chlorinated water and non-chlorinated water, and the non-chlorinated, of course, contains 0 amount of chlorine. Then there's a value for conductivity and TOC, and these are the 3 parameters that the test waters for this standards are described. And now if I would want to insert a new test water, I would just, I could do it in many ways. One way would be just to clone this field. So now you can see there's another one exactly the same as this one appearing here. Maybe if I did chlorinated test water, I will just change this value here. And then if I would add some chlorine there, and maybe it's otherwise the same. So you can just describe the basic information about the test waters in these Euclid fields like this, using the repeatable blocks. And most cases for the organic materials, for example, you would have, I guess, 1 or 2 blocks like this. But that would, of course, depend. And you have to think about your own case when you're filling this. This is just an example. Then again, there are these fields where you can insert further information, like further details on study design, in case you feel like you need to still explain something to us. And as said, because we are only seeing what we are having in the applications, so the more you can explain things, the better it is for us to evaluate and also for the risk assessment committee. Also, there's a placeholder if you want to insert the study design schematics that you show in a pictorial form, what does the study look like, or the setup. And finally, this field called any other information on materials and methods, including tables. So there are plenty of places where you can fill in extra information, for which there are no dedicated fields still. Okay, now basically what you've done is you've described your test material, your guideline, your quality, and the study design. And then there is an important section called results and discussion, and this is the section where you should insert the main results from the migration study. And this happens again using these repeatable blocks like for test water. So the repeatable blocks have these fields. So first you need to indicate for which substance the current results are. So each one of these repeatable blocks will give the migration concentrations for one particular reference substance. So of course, when you conduct your migration test, before you do that, you should have an idea of which substances you need to try and capture in the water, analyze how much there are, and then you can fill in the results for those. So here, for example, it's the vinyl chloride monomer that we are interested in. And this is indicated here using the reference substance. So this is actually good because you can use your reference substance library to indicate the same substances that you have probably created before in substance identity and intended uses sections. And you can just select these from the list of library of substances to indicate which ones you are describing the results for. Then here you can also select from a pick list what is the type of the substance that you are describing the results for. So this can be the applied for entry itself, a substance constituent, niaces, so impurities, degradation products, byproducts, reaction products, and then other. So you can just indicate which type of substance it is that you're giving the results for particularly. Then you can indicate the test water type, so which water was this test conducted, the migration period, and then there are these curiously named fields which look maybe a bit cryptic, but you can use the question mark again to use to give an indication of what they actually are. So the ATN is actually using the standard notation from the migration standard EN 128.731. And this is the concentration of your chemical species measured in the migration water at temperature T and migration period N. And the first measurement, of course, because the standard requires you to do duplicates. And here it's just that for the first measurement, the concentration was 10 micrograms per liter. Then the ATN2 is exactly the same thing. So the concentration measured for the second measurement, so 9. And the ATN AVG is, of course, the ATN average. So the average result from these two measurements, which is 9.5. Then these three fields with the BTNs, they are actually similar that they give the concentration, but the B refers to blank measurements. So these are really blanks measured from the migration test water without the sample. So how much is there some background coming from anything? This is a routine laboratory practice. And here the first measurement of B1 is 0, the second one 0 as well, and the average is 0, of course. And then this field here is called concentration in the test water, so CTTN in micrograms per liter. And this is again following the standard procedure of the standard how you calculate your concentration in the water. So it's basically explaining quantify the concentration of the assessed potentially relevant chemical species in the test water as A minus B. So basically, how to calculate this value according to the standard. I hope this is, again, maybe familiar to many. many people. It's actually that you get this value by taking the A average and then subtracting from it the B average. So 9.5 minus 0 here is 9.5. And this is how you get your concentration in the test water from the migration test. Then, of course, following this, you need to calculate your average migration rate, because we are not really interested in the concentration per se, but the migration rate. This would tell you how fast things would be building up in the water. So this, of course, you obtain from your concentration in test water, and you divide this value by the surface to volume ratio multiplied by the time, or so 3 days. In this case, if you use a cold water test, you have 3 days of migration period with a certain surface to volume ratio. So you divide this concentration by that number. And here is actually, yeah. So, and here is a conversion factor that is then indicated. So after calculating the migration rate from your test, you need to then convert this to a real world CTAP value. And you do this, of course, by utilizing the conversion factor that we discussed yesterday. And this is coming from the intended use and the kind of product you are using. So in this case, for example, if we would be using this in a pipe, in a small diameter pipe, we would probably have the conversion factor of the highest sort, so 20. And then to get the CTAP value that is then actually used in the risk acceptance later on is obtained by multiplying the average migration rate with the conversion factor. And here I would just point out that the standard actually uses for migration rate milligrams per square decimeters per day. And usually the units that are used for migration values are migration micrograms per liter. So here you have to be a bit careful when indicating these different units to get the right values. But here, for example, we get this CTAP of 10.4 micrograms per liter. And this is then the value that will be used in the risk acceptance afterwards, comparing this with the CTAP. Finally, for the results, when you have this CTAP value, then you can decide, is this a relevant chemical species or not? And in this case, well, it's migrating much above 0.1 micrograms per liter. So yes, this is a relevant chemical species indeed. So if there is no MTC tap, you would need to provide toxicological information for this. And the 10.4 here, well, that would fall into the medium migration tier. So you would have to go with whatever requirements there are. Finally, there is again this any other information or results, including tables. So you can fill in some information if you feel like you still have something to disclose. And finally, attachments. And at the moment, importantly, you should always attach the documentation concerning the ISO 17025 quality. So however you demonstrate that you follow this quality, then you should always attach it here. And as said, easiest would be to provide us with the certification of accreditation from an accredited laboratory. Finally, there's a section called applicant summary and conclusion. And here's a field called conclusions. You can just briefly conclude what you think was the outcome, and then confirmation and justification of relevant chemical species. This is a field where you can write text. You can also insert the table like this. Here I've just indicated, so chemical species, vinyl chloride, CTAP value, and RCS. And so the RCS refers to relevant chemical species, of course. And yes, it's a relevant chemical species. So confirming that this vinyl chloride indeed is a relevant chemical species. So this is now concerning the migration test demonstration for organic materials, and this is now concluding it. So we've gone through the whole document, and please, if you have any questions at all, keep submitting them in the Slido and also our help desk, because this is something we are constantly working on to improve. It's a new study record, the first of its kind. So any feedback we get is always helpful. And now, actually, since we are still on time, I will move on to the next document, which in this case is demonstrating the migration for the metallic materials. So this is just to demonstrate how different this is for the organics and hopefully give you some insight how this should be filled in. So now I moved on to this data set that I've created for metallic materials. And again, the migration, similarly to organics, is in section 5 in the table of contents, 5.1 to be exact, data on migration of the substance. And I've just titled this migration from this copper zinc 3,3 alloy. So of course, as shown yesterday also, you can write here the title by double clicking and then just typing whatever you want. And usually it's a good idea to give a descriptive name. This will help in navigating with the documents. So similarly to the organic materials, there's first the field where you choose the material type. And here, again, I mean, there's the 4 options on metallic materials. So that's hopefully not difficult. So just choose the correct one. And then the dynamic content rules will show you different fields according to this selection. And then in administrative data, again, one of the important points here is to choose a type of migration information, and most cases it will be experimental study. But just to show the difference between these metallic materials and organics, if I click on here and I will see the pick list now, so you can see, as I said before, that now we have 2 options which are black, so they can be chosen, the experimental study and the scientific dossier. And these modeling, diffusion-based modeling, full transfer calculation, they cannot be selected because they are not relevant for metallic materials and not an option. So this is to help you not to make the wrong choices by accident. Then as for the organics, you can indicate the study period, start date and end date. And here, actually, the period here is 6 months. If you follow the metallic standard, testing standard, the one, the EN 156641, the normal length of that test is 6 months. And of course, again, choosing reliability. And well, yeah, these fields are not relevant. We will probably get rid of them in the future versions. Then moving on, as for the organics, this is the same as for it, exactly the same, the study report or the data source, where in this field reference, you should fill in the details of the study report from the testing facility and add really here the full study report and also any annexes if there are. So all the details from the test, you should put them here in this section of data source. Also make some claims about the data owner and data protection claim. Then after you've given the data source, then of course you need to describe the test species in this section, materials and methods. So here for the metallic materials, you just of course have to choose the category of the test piece, and this should of course be representative of whatever it is that you're declaring to apply for. So if you're applying for some alloy, the test piece should really reflect that alloy that you're applying for. In this case, we have the copper zinc alloys category. Then the production of the test pieces, there is a name of the test piece producer again, and this is again confidential. Then for the metallic material itself, you need to indicate the basic fabrication method from a pick list. So there are these casting and mechanical forging methods, of course. So basically alloys are either cast or then mechanically formed, and all these options are here, and also the other to indicate the main production method. Then in case there are any heat treatments that are necessary, in some cases there could be heat treatments, for example, improve corrosion resistance by dissolving one phase to another or something like this. You can indicate it here. There's a field for it. And also this is a pick list field, so you can indicate annealing, hardening, stress relief, or some other, whatever is the heat treatment meant for. Also, you can indicate the surface finalization method, so grinding, lathing, something else that is used to produce the test piece. Then you have to also indicate, and this was actually a legal requirement for metallic and inorganic materials, the composition of the test piece. And this can be simply done by using the repeatable list table. So here I've actually pre-filled rows. So there's the element. So this is again with the reference substance. And if you've actually done this, for example, these basic elements like copper for when giving the substance identity, you can use the same entries here. So it should be easy to just do. You don't have to create anything new. Just use the ones that you've already created. And then you indicate the type. And for metallic materials, basically the only selections that you have here in the pick list, it's either a constituent or an impurity. So nothing more there. So just either it's intentionally there or unintentionally and just there because you don't want to or can't get rid of it. And then again, indicate the concentration of this element in the test piece. And again, this is where you actually have to provide a number, the average that you analyze from your test piece. And then you just give us the full composition. And as with the other lists, these can be filled by, you can add rows by clicking on this new item here, or you can also clone something by pressing here. And then from this, you can just easily change something here, and you can fill in this quite quickly, I hope. And also you can delete rows if you need to. So this is a hopefully simple and easy way to fill in this composition. Then, of course, in the Annex 4, it is really a legal requirement to conduct analysis using proper methods. So here's a link again to the section 6, the analytical methods, where you can indicate the details of the analytical method used to analyze this test piece. So you can give indications of how reliable the analysis is, whether it's of sufficient quality. Then for metallic material specifically, there is a field where you can indicate the roughness of the inner surface of the test pieces. And at the moment, we are still discussing a little bit what this value actually should be, or if there's any, but it's a legal requirement that this has to be provided. So it's here. Then there's a field called any other information again. So anything that you may have missed or there's no field for it, then you just provide it here. And this is a text field for anything that might be missing. Then after you've described this manufacturing and the composition of your test piece, we move on to the physical characteristics, again, a legal requirement. So shape of the test piece, here you can choose it. And again, there's the same pick list. If you follow the testing standard 156641, which in most cases you should, the shape of the test piece is pipe. So it's either a long pipe or a shorter pipe called pipe piece. And then you can describe physical dimensions. Again, if you follow the EN 156641, there are specifications of what shape or size the test pieces should be. For example, here's the length of 100 millimeters, inner diameter of 17 millimeters. Again, the layering, well, this is the bulk material. It's not plated, so it's a single layer. And this is, again, you can choose from a pick list. Mostly this should be single, unless for platings. Then there's, again, a field for storage of the test piece where you can describe where your test pieces were stored before the test, how long they were stored. And any treatments just prior to testing. Metallic materials, often they gather moisture and oxides on the layer, on the surface, so maybe there needs to be some treatment just before the test. I don't know, I'm just speculating, giving examples here. Then one really important section again here is the same as for the organics, the test guideline. So in this section, you need to indicate whichever guideline or non-guideline method was followed to do the test. And here I pre-filled this row. So there's a field called qualifier according to guideline. Then the actual guideline, the EN 156641, should be mostly there. Version remarks, so most recent, and accredited for the method. So basically indicating that whoever did the test, they have accreditation for it. Deviations, no. And again, if you need to add something here, you just click on this new item and then you choose from these pick lists the values. And for actually metallic materials, there are only two test standards that are listed here. So the 156641, which is a standard legal requirement. And then there's the EN 16058, which is equal in the way it's done for the 156641, but it's meant for assessment of platings. And then there's the option other. So if for any reason, which I hope that is not the case, you would have some other way of doing this, then you should indicate that. I will delete this row now. And if you do not follow the standard that is legally required, if you some reason do something else, then you have to really explain the principles of the method. So this EN 156641 will be used as a point of reference for assessing the metallic materials. So deviating from that, you have to have a really, really good reason. Then again, here is the quality assurance. So this is again exactly the same as for the electrochemical test and for the organic materials. So indicate either this 17025 or other by choosing from a pick list. And in most cases, it should be the 17025. And then in remarks, of course, you can indicate, for example, that accreditation certificate in the attachment. So you have to provide documentation for this. I'm repeating myself, but that's really important. Now you've done all this, you've described your test piece and your processing of it and given the data, the full study report. And now there's some basic information about the study design that we are asking. So the test waters mainly. And here you can indicate in a similar kind of repeatable block as you did for organic materials, the the test waters that were used. And here are some different parameters, and this is because the main standard that is used, the 156641, it has a part 2 that describes or specifies the test waters that should be used in testing metallic materials, which represent the corner waters of different water qualities in Europe. And you can use these repeatable blocks to really fill in the information on how many test waters you were using. So the amount of test waters that you should fill in here, that would vary whether you're adding a composition to an existing metallic material category or if you are creating a new category. When you are creating a new category, you need to test using 3 test waters, all the 3 test waters specified in the standard. And you can do this by adding these blocks, either by cloning or clicking on the new item here. You can have an empty one, or you can just duplicate this one and then start changing parameters, choosing the right ones. And of course, the specifications of these should come from the test report. But you can add the necessary amount of test waters here from 1 to 3, anything you need. And then that's good. Then there are 2 fields, further details on study design and study design schematics, where you can insert information if you need to, any further details or study design schematics. And again, any other information on materials and methods, including tables. So, but if you follow the standard, probably you don't need to do much here. Then for the results and discussions for metallics, as said, basically what you should do is give the main results that would be used in evaluating the results for the risk acceptance. So the experimental study migration test results for metallic materials. And for metallic materials, you can use these repeatable lines here to give the basic information. Here I pre-filled all these rows. So this is what it looks like. So you would have to indicate the test water by selecting from a pick list, one of the 3 options. You need to indicate the reference substance, and you can use your reference substance library. Again, you should already have created this if you're doing migration testing. Then you need to indicate the time period or week of operation for this particular test, the 156641 that is used, and there's a legal requirement. So the evaluation points are these 3 periods of operation, the week 16, 21, and 26. Then from the test results from the laboratories that's doing the test, usually they should provide you this arithmetic mean of the equivalent pipe concentration, so the MEPA value. And this is what you should provide here. This is the value that is then used together with the A factor, or the relative contact area of the intended use, to calculate the CTAP value concentration at the tap, which is used then in the risk acceptance. So here, the A factor is now 10%. So of course, there's a pick list you can choose, and this actually follows the product group that you are declaring as intended use. If you remember the letters A to D, so A was 100, B was 10, C was 1, and D was less than 0.1. But here, this use was declared for the group B, from B to D, so we are using the 10. And then when you multiply this by 10% or 0.1, you get 100 micrograms per liter, and this is the CTAP value then used in your in the risk acceptance. And so you just fill in these lines for all the relevant chemical species that you have to analyze, and for metallic materials, what you have to analyze in the migration water. This is actually stipulated in Annex 4, Section 1 of the Decision 365. And as you can see, sometimes you may have quite a large number of rows, but with the cloning and adding new items, it should be relatively straightforward and easy to do. Okay, then there's again in a field where you can add any other information. In this case, just added as an example, a reference to the analytical method standard, but this should be in section 6 in any way, and this is something I will demonstrate shortly afterwards, after this section. Again, in the very end, there's this section called attachments, and this is the place where you should really attach the quality assurance document, whatever it is, either accreditation certificate or something else to show adherence to ISO 17025 or equal. And finally, there's the section applicant summary and conclusion, where you can conclude what happened. So migration study of all relevant elements was conducted, and then confirmation and justification of relevant chemical species. So for metallic materials, you can refer to the legal text where it says which ones are the relevant chemical species from constituents and impurities. So for this one, according to this legislation, point 1.4b, the constituents that are relevant are copper and zinc, and impurities that are relevant are nickel and lead, and they were all analyzed in the migration test water. And that's it. We are now at the end of the migration for metallic materials, end of this section of the workshop. So I thank you for your attention. I hope it helped, and please send in any questions that you have, because it always helps, especially when we're developing something new like this. I think I will now continue onwards to the analytical, or should we have a coffee break? Okay, so we will have a coffee break, and we will be back at 11:45 and Helsinki time. So enjoy your break wherever you are, and see you soon. Hello, you're back. I hope you can all see and hear us. So now you're moving on to the next section in the workshop. So the next section, I will talk about the analytical methods section in Euclid and give a practical demonstration how it's supposed to be filled for different cases. As said, the analytical methods section here specifically refers to analytical information details regarding anything related to the migration. So what is specified in Annex 4 of the implementing decision 365. So basically the analytical methods study records in section 6 of the Euclid drinking water application, they're used for 3 types of different analytical information. First, there's the targeted analysis of chemical species in migration water. This is, of course, the main use for it. So when you do migration test, of course, you have to quantify your substances in the water. Otherwise, it's not going to be very useful. And this is mostly done by targeted analysis. And then there's the non-targeted analysis. So if you do screening analysis for unexpected substances, also you can provide details for these in this section. And finally, there is the information on the compositional analysis of the test pieces that you have to do to quantify and demonstrate that your test pieces are of representative and worst case quality. And just really to highlight that the section 6 in Euclid, it's really used to provide the details and the performance characteristics of the analytical method. So the actual results, the concentrations, they would be in section 5. So this is really to describe how reliable the analytical method was that you were using. And this is actually specified also in the legislation, what kind of quality the analytical method should be referring to. Then just briefly again to show where to find this section in Euclid. So it's the section 6, as I was demonstrating already slightly there in the migration. So it's right below the migration section, and you can insert there the create records and insert data there. And unlike the study records for intended use and migration, the analytical methods for migration is actually what is known as a harmonized template in Euclid, and it is used by many legislations, the same template. What this means basically is that we cannot fully customize it to our needs. We can do some customization, but sometimes it could be that there is some things which are not relevant to drinking water specifically, but we are of course trying to make it as user-friendly as we can. And what is required from analytical methods concerning migration are, of course, they are outlined in the legal text of Decision 365 and Annex 4. About the structure of the analytical method study record, it's quite similar to migration and other study records. So there's the administrative data, there's materials and methods, results and discussion, and then attachments and applicant summary and conclusion. And in this case, I have tried to mark in bold and red some sections where the information given there is really important and should always be given. For example, the type of analysis, a cross-reference to migration, and this would be there to indicate us what kind of analytical method we are talking about. Is it targeted, non-targeted, or something else? And of course, the cross-reference to migration would be to really indicate which migration test or study this analytical method is referring to or where it was used. Also, in the materials and methods under that section, you should really give a reference to test guideline or the analytical method standard that was used, whether it was a standard or non-standard. Also, it is very important to describe the test material, and they should basically be, for example, for migration analysis, the migration water. to give out which chemical species were used by this analytical method to quantify them. And then, of course, the results and discussion, in some cases, they should really be used to fill in the validation characteristics of the method in cases where those are needed. And the attachments section should be used to give the analytical report that the laboratory conducting the analysis should give you. And these are the important things that should be filled. And I will demonstrate them for all kinds of analysis in this section as well. So just to be more specific about the key information I was highlighting there for the administrative data. So there is this field called type of analysis. And in this one, you must really indicate what kind of analysis you're doing with this particular method. Is it targeted, non-targeted, or composition of a test piece? And also there must be a cross-reference to the relevant migration study. And this is just for the sake that if we have all these analytical method study records and migration study records, and there's no link between these, it will be quite difficult to know how the analysis was conducted. So this is why there must be this link made. Then the test guideline. As for the migration tests, you need to indicate in this section test guideline which analytical standard was used to analyze the relevant chemical species from the water, or if it was a non-standard method, they should also be disclosed here, and then the method described. And also, as with the migration study, the ISO 17025 quality and any documentation demonstrating this quality or equal should be given also. And these must be given in the migration specific fields, and also the attachment must give some demonstration of how this quality was really followed. The test material, it's also very, very important. You need to use this test material data entity to provide details of what was analyzed, whether it was water or test piece, and which chemical species were analyzed from this test material. So this is a place where you can easily indicate which substances were analyzed with this method. And then again, results and discussion. So here I've highlighted actually the legal requirements. So it's the point 5.3 in Annex 4 of the decision 365. So it says that the analytical methods and techniques shall be validated. So it's a legal requirement to use validated methods. And now what exactly are these then? So there are standardized analytical methods, which when used within their scope of application, these are considered already validated. So because these are publicly available, they are known, there are explanations how they work, and they have already been tested and tried. So when you are analyzing something like this, for example, analyzing metallic elements using a standard ICP-MS method, where the elements that you're analyzing are within the scope of this analytical method, there's no need to validate this anymore because it's already been done, so you don't need to provide us any details for it. And then again, anything else than standardized or guideline methods used within their scope are considered non-validated. So these are the cases where you use really an in-house method developed specifically for this task, or when you have to modify a standard method to widen the scope to really include also your element that you're trying to, or substance you're trying to analyze. So modifications like this, you need to validate. And actually, when you follow the ISO 17025 quality, the default is that laboratories accredited under this standard, they have to validate all the methods that they use. So this validation information is not something that nobody would have to generate as an extra. So it's something that they would have to do in any case. Then what is validation actually? And this is a definition that comes from the ISO 17025, so a demonstration that an analytical method is suitable for intended use. So probably, I hope this is something that everybody is aware of, but validation is really just measuring certain performance characteristics to see how reliably the method is able to quantify something in the sample, the water, and how reliable the result would be. And this would be done mostly by evaluating certain characteristics, which are standard practice when you're doing method validation, detection, quantification limit, selectivity, linearity, trueness, precision, and uncertainty. And in ECHA Guidance Volume 1, there are more information about the requirements for method validation. We will also try to always keep this up to date, so any comments there are concerning this is also welcome. Then about the results and discussion, as said, when you are doing analysis with a validated method, so then there's very little information you need to provide in this section. So basically the analytical report, but that's it probably. So on a case by case, it could be that you should provide some details like the limit of detection, limit of quantification, probably should be reported in the Euclid fields always. But this is, of course, when doing the risk acceptance, it should be analyzed by case. When you use standard methods, usually the standards indicate, or the guidelines, they indicate what kind of details should be given in the analytical report as a default. But in some cases, it is useful to provide some extra information, particularly, for example, if your migration or the CTAP value is really close to the empty CTAP, and you really have to think about whether it's above or below, then limits of detection, limits of quantification, uncertainties, precisions, all these become more important. Then again, for non-validated methods, you really need to fill in the information concerning the validation criteria. So this is something that you really have to do when you're using a non-validated method. And just in the screenshot, there are two things which are shown. So there's dedicated section where you can insert recovery results. Also dedicated section for limit of quantification, limit of detection. And then for the other validation criteria, at the moment, we have this free text field where you have to describe all the other validation criteria or the parameters. And in the future, we will revise the Euclid document to have also dedicated fields for this for ease of use. Then key information concerning the attachments. So what would be needed are the following documents here. So for the validated methods, when you use a standard method where all the analytes are within the scope of the standard method, all we need would be this analytical report, the basic report that should be given by the laboratory conducting the analysis. For non-validated methods, the information we would be needing would be first, for example, of course, the validation plan, so how you intend to demonstrate the fit for purpose of the method. And of course, the raw data and calculations that you obtained from validation. Validation report, approval, and SOP, and this could be, of course, not necessarily 5 documents, but the information should be given to us anyway to have idea of how the validation went. And now, actually, I don't have any more slides on this section, so I will go on to live demonstration to show 2 different Section 6 study records, one for a validated method, what needs to be there, and one for a non-validated method to give a flavor of what is required in these 2 different cases. Let me just try and switch to Euclid now. So here we are in Euclid, and I will go first to metallic dossier, which contains an analytical methods section for migration using a validated method. So this is, as I was saying, so in the top, there's the analytical method section here on number 6. Then there's the name of the dossier. I gave it some descriptive methods, so copper zinc alloy 33. And TW1 refers to test water 1, migration water analysis. So try to describe what exactly is the study record detailing. The first section on top here is administrative data. And here, as said, it's very important to fill in the type of analysis field. At the moment, we cannot change the pick list to have dedicated entries for these, but you need to use this field other and then describe by writing what kind of analysis you actually are going to do. And to help you remember this, there's a help text which explains what to do. So in the additional text field following other indicate the relevant type of analysis. So you can even actually copy paste this text from the help text to insert into the field. So it should be relatively easy. And normally this field is a pick list, but as you can see, there's only one option here. So only other, and then choose one of the 3 types, or write one of the 3 types of analytical information or details that is covered by this study record. Again, as with the other documents, you can indicate the dates. So when was the analysis done, and the reliability. And this is the same kind of classification as with the other sections. Then there are some fields that you don't have to really care about, like rationale for the reliability and data waiving, justification of data waiving, touch justification. So when you are filling in an analytical section document which is using a validated method, the next thing after this administrative data you need to fill in is the migration cross-reference. And this is the place there for it. So basically here in this related information, you can click and then you can just shows you the document it's referring to. But if I would just remove this, I can click on the plus select, and then it shows me the Euclid table of contents. And there I can scroll down to the relevant study record. So I'm linking it to migration record, and I click there, and it will be linking me there. And then when I click this, I can go to the migration study to see what this analytical document is relating to. Besides this migration cross-reference, as said, you need to fill in the test guideline. And it's really important to provide us with a reference to the method used. So either a standard method, like in this case, or a non-standard method. And here, this is an example for a validated method. So the analysis has been done according to guideline. It's using the EN ISO 17295 Part 2, which is an ICP MS method to determine selected elements. I think it contains about 40 different elements. It covers most of the metals in the alloys. The analysis was done with a version of 2016 and by a laboratory accredited for the method, and there's no deviation. So this is the easiest case. So it's an EN ISO method, so publicly available within the scope, so no hassle there. And just again, to give you an example, this guideline field here is a field of pick list, so we can just scroll up and down and choose whatever method you need. But what is important here is that we need to have some kind of reference to the method that was used to analyze. And there's also the option to choose non-guideline and then explain. But this was an example now for somewhere where you just done the analysis strictly by the book according to this method here. So then when you've done this, you need to also indicate again the quality assurance, so the ISO 17025, and the relevant documentation. So for example, it was conducted by Supralab 1, accredited for this method, and quality assurance statement provided as attachment, indicating where it is. So this is good. Then there's just indication on that the matrix was drinking water. So this is, of course, something that is good to point out. Then after the guideline and the quality assurance, as said, it is important to indicate in the test material data entity what was actually analyzed. And here you can click on this and you can again indicate this kind of test material, where you can indicate its composition, the different constituents and their concentrations. And here, the matrix, of course, it's drinking water, so it's water. So this is not maybe necessary, but here would be the elements that have been analyzed with this method, and they all fall within the scope of the method. You can also provide other information as necessary. For example, test material form, of course, it's liquid because it's water. But it's very important to have this test material filled in so we can see what was actually analyzed with this particular method. Then here you can give some basic information if you want. So the instrument detector, ICP-MS, multi-analyte, sampling pretreatment flow diagrams, further details. So you can actually insert here some really descriptive things about the parameters used in analysis and other descriptions. But then as we move on to the results and discussion, because this is now something where it was a validated method and within the scope, so there's nothing much really here to fill in. There is still, as said, on a case by case, you could be able to maybe provide the LOQ and LOD, because some of this information might still be needed to really evaluate the analysis. But then beyond this, what you need to give is the full study report, so the analytical report given by the laboratory conducting the analysis, and also the relevant documentation demonstrating adherence to the quality ISO 17025 or equal. And in this case, we have this section called attachments where they should be provided. We will have in the future for this method, for this section as well, the data source, data entity as for migration studies. So it would be similar to those then. But at the moment, we don't have it here. So this is still pending. So for now, use the attachments section for these. And then there's the applicant summary and conclusion. So validity criteria, well, there's nothing to be validated here. The method already is validated, so that's fine. And this is really the information that is needed when you're using a validated method within its scope. Okay, so next, I will now demonstrate the information required when using a non-validated method. So I will go on to the organic study record or dossier. And here again, I have analytical methods for migration and characterization and something called targeted analysis of migration water. And again, here, so as with the other section, it's important to indicate what kind of analysis was performed. So here in the remarks field, it was written that the type of analysis was target analysis. Also, you can indicate the study period and reliability. And then the migration cross-reference. So here it's actually similarly to the metallics, you need to provide a cross-reference to the migration study record, which in this case would be the vinyl chloride and PVC. Clicking on this, it will take me to this migration document. You can see what's here. So this will link the analytical information nicely to the study in question. And then here is where we start differing. So the materials and methods. So test guideline, well, unfortunately, for some reason for this analyte, there's no guideline available. And then this principles of method, if other than guideline field, should be used to really explain the method. So scope and application, principle, responsibility, safety, equipment, sampling procedure, calibration, give this sort of explanation, what is the principle of the method. And the more you explain, the better, of course, for us to evaluate. Then you still need to give some quality assurance. And of course, in the case when there is no method available, laboratory creates their own, for example, they still need to have competencies to do analysis of in water using some analytical technique or something like this. So the scope of their competence should still be following the work that they're doing. But yeah, again, as with everything, so you need to indicate the ISO quality and give documentation about how this is demonstrated. Here, again, it's the explanation of which matrix was analyzed, so migration water. And also, as with the other analytical type, you need to give the test material information in this data entity called test material. So just clicking on this, and then it'll open up this place where you can describe your material, give the types and concentrations and names of the components that you're analyzing. Then in the case where you're using something new, it's important, of course, to describe it. So here, select the instrument detector. This is something, again, that you can choose from a pick list. So here, in this case, it's GCMS, and also indicate whether it's multi-analyte or single. Describe the sampling method, give a flow diagram, and explain some further details. Then any other information on the materials and method, including tables. And then we come to the important part where if you are using a non-validated method, you need to provide the validation details. And this is done in this section called results and discussion, actually. So recovery was one, and then you need to provide information on recovery. And you can do this by these repeatable lines. So you can add new item by this plus sign as for the other sections where we have the same functionality. You can click on this, and then you can use this slider here to move because it doesn't fit into one screen. You can use the trash can icon to delete a row. You can use this icon here to clone a row. And basically the information that you insert here is just the name of the analyte using the reference substance again. So if you've already done substance identity and migration, then you should probably have all these already in your library. If not, then you can create them. Then describe the matrix. For in this case, it's test water. Then, because it's recovery, of course, you give the fortification or spiking number of replicates. Then the range for all the recovery experiments that you measure, the mean recovery, and the RSD in percentages. And here, of course, in the remarks, it has been described that the acceptance criteria is 96 to 104% recovery. And it seems that the recovery is within these acceptable limits. So it seems in this respect that the method is performing well. You can also give additional details on recovery results. Then the LOQ-LOD. Again, you give the analytes, the matrix, and then what was the limit of quantification, what was the limit of detection. And then you can explain further. And here, for example, it's explained that these are based on signal to noise criteria. And the sensitivity seems to be adequate for detecting low-level migration. Then there's a field for calibration that you can provide. So again, it's the analyte for which the calibration was conducted, what kind of standards were used to calibrate. And this is something where you can choose from a pick list, matrix matched, internal standards, something else, like standard reference material, perhaps. And then the matrix, drinking water, calibration range. They should, of course, cover whatever it is that you are analyzing within the equation. In this case, it's a linear equation. The correlation coefficient, and actually the coefficient of determination as well. A number of replicates. And then moving on here is a field for remarks. So, and then there's a field for matrix effects. In this case, we are just saying that, yeah, it's 0. and they were within acceptable limits. And then, because we have more validation and performance characteristics that we are requesting than there are fields in the Euclid template, we are using for now this free text field where you have to provide the additional details. So you have to describe selectivity, linearity, trueness, precision, and uncertainty. And of course, linearity is part of the calibration, and trueness relates to recovery, as was indicated above there. So, but these are some things that any professional analyst working in a laboratory by accredited ISO 17025, they should know how to validate methods. Then when you filled in these details, there is this field called overall remarks and attachments. And then finally, what is really important, as said in the attachments section, when you do the validation, you need to indicate the relevant documentation like the validation plan and the validation report, and then whether it was approved or not, and the standard operating procedure and all the raw data related to this method validation. And finally, just to summarize things for us for quick evaluation, there is a section called validity criteria. So here you can really summarize the validity criteria that you were using, like selectivity, no significant interferences, and then what you did observe and whether or not you think the validity criteria was fulfilled, yes or no. So for selectivity, for linearity, what was the criteria? Trueness, recovery there, mean there. Precision, RSD less than 10%, it was 5, so yes, and so on. And then you can conclude, and then you can give an executive summary of the details. So this is basically it. So the main points here would be in the section called administrative data, what kind of analysis it was, and then providing the cross-reference to migration study, providing information on the guideline or non-guideline if not, and then if it's not, then explaining what was actually done, providing information on the quality, the test material, describing the analytical method, of course, and then giving information on the validation, of course. This is really important when using non-validated methods. But it's also something that a laboratory operating under the right quality should provide as a normal thing, because they have to validate all the methods they are using. But that's it. This actually concludes my my presentation and demonstration for the substance for the analytical section. And as always, any comments, questions, either through Slido or our help desk are more than welcome. Thank you. I think we will move on now to the next part. So next we have the Q&A, and this Q&A is now specifically dedicated to migration and analytical details, I think. So let me just try and switch the screens. So here, first Q&A session. So primary focus. Yeah, let's not go on a break just yet. Yeah. It's here. Is now. Should I start reading the questions or? Yeah. Yeah. So let's see, on the top of the screen, I see this one question. DVGW/Kiva/ACS certification can replace migration tests or must be done separately. So I'm not really sure I know what these certificates are. I do know DVGW and Kiva. Perhaps it's some kind of product certification. But I do think that when you apply to us, you must provide migration test results. So if these certificates, they somehow contain or include migration tests, then that is something we should have. So, but the certifications as themselves, I don't think we can replace migration tests by those. Okay, should we move on to the next one? Well, it's an interesting question. How can applicants commission a worst case use migration testing if the highest concentrations in water can only be known at the end of the experiment? Well, this is an interesting question, of course, and I'm not really sure if there is a simple answer to this. So there are some indications, or let's say some parameters which affect migration, and this is, I guess, quite well documented in the scientific literature, which you can use as your guideline. We have some in our guidance, volume 1. For example, if you would be using your substance in an organic material in a cold water or hot water, then probably hot water would be the worst case. But of course, there is something, because there are many factors involved. It can be that you don't know it until at the end of the experiment, but because you would be still, it would be very wise to test all the intended uses for migration, because certainly when you have the different migration test results for different testing, then you would really see what would be the worst case, and then the evaluation for the acceptance of European positive list would be based on that use. And then if that use would be accepted, then anything else that you tested where the migration was less than that would be accepted as well. So this is the way to go. But yeah, you cannot know for sure before the test, of course, but you can try and design the test in such a way that the parameters in the test would be such that the migration would be the worst case, like highest concentration in the material, or the hot temperature, maximizing surface to volume ratio, having a really, really low density material, and something like this. Yes, then moving on to the next method. Again, a really, really, really good one. For UVCBs, what characterization and analytical method validation are expected for migration testing, especially where peaks are only semi-quantified? And if UVCBs require a vehicle, how should vehicle-related effects be addressed? So, of course, we would expect only that you do the best job you can. We are aware that for some really complex substances, validating method and characterizing them and then doing really precise analytics can be really, really challenging. Semi-quantified, I guess if I understand this correctly, it could be that it relates to more screening than targeted methods. So yes, I don't have really a good answer to this one as well. So we would still expect you to try your best to validate the method. I would assume that whoever is doing the analysis, they would know how to do the best they can, and then explain it to us. So that is actually important. You just explain what you did, how and why, and then the scientific committee would evaluate that, and then it should be the result that you're getting. And concerning if the UVCB require a vehicle, how should the vehicle-related effects to be addressed? Not sure if I understand what the vehicle refers to, but maybe it means that you need to have some kind of carrier for the UVCB or another substance that could affect the results as well. As again, well, the laboratory conducting the analysis, they should just explain what they did, why, and how, and then they should be evaluated by the scientific committee, and then you'll see what will be happening there. So I don't have a better answer. Sorry, but it's a very good question. Then I will move on to the next one from Axel Jörg. Should I include in section 5 our own analysis of the metallic material, or that which provided the accredited laboratory performing the test according to EN 15641? The method could be different. Yes, so section 5 is actually the migration testing. So there you should not give any analytical details. You should give them in section 6. And whatever is the method that you really used to analyze the composition of the test piece or the metallic material, this is the one that you should be providing the details for in section 6. So in the case, if you have an accredited laboratory performing the test, then you should really provide the results or the details of that method, so the reference to standard. And then in section 5, you need to provide the composition of your metallic material test piece. And also, in case if this is referring to migration water analysis, in section 5, you need to provide the results from the migration water analysis. And in section 6, you should provide the details of the analytical method used to conduct that analysis. I hope this helps. Then I will move on to the next one. Can you please provide a list PF, C, and test standards related to DWD migration test? Well, there is a kind of a list in the legal texts. So the decision 365 indicates the 15664 for metallic materials, also the EN 16056 for the electrochemical test, the EN 16568 for testing platings, and it refers to another implementing legislation which indicates the EN 12873 for organic and inorganic materials. And also ECHA guidance mentions all the standards that you need to do migration test. There are not many. There's only one for organics, one for cementitious, one for enamels and other inorganic materials, and 3 for metallics. And these are all listed in the legislation and also in ECHA guidance, if it's easier to find it from there. Moving on to the next question. 2024-368 requires testing of 3 migration periods, the third for evaluation of compliance, the other for showing falling tendency of migration. Is it sufficient for the dossier to analyze only the third cold water or the 7th warm hot water period? If not, where are the remaining results reported? Yes, so the 368 is about product certification, product acceptance. So there they also investigate for organic, cementitious, and inorganic materials, whether or not there would be an increasing or decreasing trend of migration, so whether migration would increase or decrease over time. For applying for the European positive lists, however, we are not interested in whether or not what would happen with product certification or products. So here we only need to have the results for the third period for cold water or 7th for the warm hot water. So nothing else. That's all that we need. We don't need to have the falling tendency of migration. But that's a good question. Thanks. Then moving on to the next question. Is it mandatory to upload quality certificates regarding the purity criteria of the ingredients? And if so, where are they uploaded? I feel like this is actually a question on substance identity, maybe. Nuria, you want to take this, or? I'm not really sure, because it's a good question. I don't think it's mandatory to upload any quality certificates. But you need to indicate the purity. But this is in section 1. I think it's about substance identity. So I hope this helps.
From substance identity, there's no requirement to provide quality certificates. So I wouldn't say that this is not mandatory from substance identity perspective, that I can confirm.
So yes, not mandatory. And of course, if you think about, for example, metallic materials, when you do migration test, you have to analyze the test piece composition, and this would include the constituents and the impurities. So the purity is sort of there. So no, it's not mandatory to have quality certificates for ingredient purity. Okay, moving on to next question. What could be the scientific dossier for migration tests for metallic materials? Yes, so I think maybe in the future we shall cover the scientific dossier. There are some criteria given in the legal text what the scientific dossier is about, when it can be used. Basically, it is a case where you have an alloy that is very, very close to some other alloy which has already been tested and accepted, for example. So you can say that its corrosion behavior in these conditions of the test would be really, really similar. So you could use it to predict the already tested other alloy, to predict how this one would behave. It's a kind of a read across for metallic materials. And this would be then a written document where this would be explained, and then there would be some kind of reference made to the already existing tests, and also explanation on the conditions of use where the alloy that you're applying for would be used. So this would be the basic contents that should be there. We have some information on this also in our guidance. So the legal text will give you some details when the scientific dossier can and should be used, when it's possible. And I think our guidance also explains something about it, but I think in the future we may even give some demonstrations on what would be the case for here. Thank you for the question. And also, I am now moving on to the next one. So cold water testing requires non-chlorinated and chlorinated water. Is it possible to waive one of the tests by a scientific justification? Technically, I think it could be possible that you could submit a dossier with just one of the 2 migration tests. And if you give justification, of course, you have to, if you're going to waive one of those tests, you'd have to explain why. So it is possible to not provide it. What I cannot say for sure at the moment is how this will be viewed by the scientific committee. It's still under discussion how strict we are going to be with these certain studies. We understand that sometimes there may be cases where it's very clear, it could be very clear, that even without testing, you could really say with a great certainty that something happens or doesn't happen. But then again, it's always easier when you have the numbers, so when you have the tests. So you can waive a guess, but I cannot be sure of the outcome. So at this moment, I would say rather be safe than sorry. But I will have to say I don't have an exact answer to this one. Thank you. Then moving on to the next question. From Zizer Attila, I hope I pronounced that correctly. In the case of an alloy coated with epoxy resin paint, what kind of migration tests are required? What are the relevant chemical species to be analyzed from migration water? So in this case, I am assuming from the question that you have a metallic substrate material on top of which you apply an organic coating or epoxy resin paint. So in this case, you would have to test a piece of metal coated with the epoxy resin using the test standard for the organic materials. So this would be, the epoxy coating would be on the organic materials list, of course. The relevant chemical species to be analyzed from migration water, these would be, of course, whichever starting substance you are applying for. I would assume that epoxy resin paint would have more than one ingredient. And all of those ingredients, if you're going to use it, they would have to be on the positive list, and you would apply one by one. So whichever substance you are applying, intending to use it in this kind of product, you would apply for that starting substance, and then that starting substance and anything it has in terms of constituents, impurities, and any reaction products during the manufacturing of the coating, those would be where you would look for the relevant chemical species. Of course, it would depend on your case. Then moving on to the next one. Is it correct to assume that the requirements for documenting the analytical method used for the migration data are the same as those for documenting the analytical method used to analyze the composition of the test specimen? Yes, that is correct. We do have the impression now, of course, that maybe for analyzing specifically organic substances from water would be more difficult, and there could be much less standardized method for those. But in the principle, the basic requirements are the same. Yes. Then moving on to the next question concerning metals. Why must we upload the values of the elements in the water in 3 different weeks? These values are also, of course, in the full study report already uploaded. Well, yes, you upload the full study report. You do not upload the values. You type them with the keyboard, just the numbers. And the 3 different weeks here specifically are because those are the weeks that are used in the evaluation and the risk acceptance of the alloy. So the results from weeks 16, 21, and 26 are used to compare the concentrations or the CTAF values against the empty CTAF values, and then decide whether or not they are below or above and whether it's acceptable. And also these weeks and some other results are used to determine for metallic material specifically whether or not there is a decreasing trend. Okay, moving on to next question. The second before last. If a manufacturer of a substance, not the last downstream user, wants to submit a dossier, which tests should be performed? Only specific migration of the substance or non-targeted analysis? In the last case, it will be very difficult for the supplier A to determine the different NIAs. Well, yes. When anyone would want to, maybe I'll start, and maybe if any of my colleagues wants to chip in, they can. So anyone who wants to submit a dossier, they should always perform a migration test, and they should do this with the best of their knowledge. So whatever material they think that substance will be used in, they should do the migration test accordingly. And then, of course, they need to determine which substances would be the relevant chemical species, and then do those and analyze them from the migration water. And also, if you are applying for a starting substance or an organic cementitious constituent for organic materials or cementitious materials, you have to always do also the screening non-targeted analysis from the migration water. So, and we will, we acknowledge that it can be very difficult at sometimes to determine all the different NIAs. Okay, moving on to the next question. In case of peroxides, which test should be performed as these substances react totally? In that case, modeling is possible. Yes, it sounds from the question that for these cases, modeling would be possible. So the criteria when modeling can be used or should be used or is acceptable is in the legal text. And I think one of the criteria, as I remember, is that if physical testing is impossible, technically impossible, then you can use modeling. So that would be, I would think that that is a yes. Modeling would be possible for these substances. Then moving on to the last question. For a prepolymer, it is in the positive list, but its starting monomer is not in the list. So a coating product made from this prepolymer is in compliance. For migration test, shall the prepolymer be tested or the monomer be tested? Sounds like a complicated case. A prepolymer in the positive list, starting monomer is not on the list. Well, if it's already on the list, of course, the prepolymer can be used to manufacture products if it's already on the list. So you don't need to do anything in that respect. Maybe I have other colleagues who can chip in, but I think if you would be applying for something like this, we have some rules which will help you determine whether the application for the European positivist would be both the monomer or the prepolymer. And then this would, of course, determine which ones you need to test for migration. But maybe if I have colleagues who want to.
I'll take this. Indeed, in the Euclid manual, in the explanation of how you fill in section 4 intended uses, there is extensive analysis of whether you should be applying for the monomer or the polymer. There is also the scope guidance document, which is volume 3, that you need to take into account. And the origin of all this guidance we are providing is actually Article 3, paragraph 4, and specifically sub-point C in Regulation 369 of 2024, which says that the application shall be made for the prepolymer in the case of organopolysiloxanes used in the manufacture of silicones, rubbers, lubricants, and surface treatment for fillers, or in the case of coatings. So when you deal with the prepolymer for coatings, then you apply for the prepolymer. Thank you.
Thank you, Panos. It looks like there are no more questions. So what are we time-wise? Are we? So we will now break for lunch. Thank you for all those useful questions, and We will see you in 1 hour.
Good afternoon. Welcome back from the lunch break to the second half of our second day of workshop. My name is Vesela Vicheva. I work as a regulatory officer in ECHA, and I'm also a toxicologist in the drinking water team. Today, with my colleague Ilari Tarvainen, we're going to lead you through the toxicological properties and how they should be filled in EUCLID. However, before I start with my presentation, I would like to note that there would be a particular Q&A session at the end of the day that would cover the questions for toxicological properties and also questions related to the presentations that are coming after this one, particularly for risk acceptance. And we are also going to answer all the not answered general questions. So please, while you're listening to our presentation, and if you have some questions related to toxicological properties, particularly how they should be reported in EUCLID or some other content questions, please write them in Slido and we'll try to answer them at the end of today. So today, first, I like to give you a quick reminder on the general considerations and legal basis for toxicological information requirements under the Drinking Water Directive. Some theoretical information on where and how to report toxicological data and where and how to waive those data in the two different working contexts in EUCLID. And at the end, we're gonna share with you a demo of an example case that we have particularly prepared for this workshop. Toxicological information should always be provided for relevant chemical species that have been identified as per Section 3 of Annex 4 to Commission Implementing Decision 365. The amount of the toxicological information depends on the level of migration of the relevant chemical species. The legal provisions for the toxicological information requirements are set out in tables 1 to 3 of Annex 5 to Commission Implementing Decision 365. This annex lays out also provisions when toxicological information can be adapted or waived. Toxicological data can be adapted either based on Column 2, specific rules for adaptation, or based on Part 2, general rules for adaptation. There are also provisions when toxicological information does not need to be provided, and this is for relevant chemical species that meet any of the criteria set out in Section 1 of Annex 5. As it's been explained yesterday during the presentations, there are two working contexts in EUCLID. DWD application working context, which is for the applied for entry, and DWD data for relevant chemical species other than applied for entry. For each identified relevant chemical species other than applied for entry, a separate data set must be created, and this data set should be linked under Section 1.5 of the main data set. This is a reiteration of what Panos has explained yesterday, but I think it is important to be noted once again. When it comes to toxicological information, there are no differences in the type of the toxicological data that should be provided under the two working contexts. The toxicological information should be filled in Section 7 of EUCLID. When you work under the DVD application working context, Section 7 should be filled only if the applied for entry has been identified as a relevant chemical species. If the applied for entry has not been identified as a relevant chemical species, or if it has been identified as such, however, meets any of the criteria of Section 1 of Annex 5, Section 7 in Euclid should be empty. Exactly the same provisions are applicable for relevant chemical species other than applied for entry. Even if there are no differences in the type of the toxicological information, there are some slight differentiations between the two working contexts when it comes to the application of the general rules for adaptation, read-across or QSR models used to cover for information requirements in vitro genotoxicity, mutagenicity. Those slight differentiations are set out in part 2.2 of Annex 5, and they state that when the applied for entry has been identified as a relevant chemical species, the information requirement for in vitro genotoxicity mutagenicity must be covered with experimental studies performed with the relevant chemical species. In other words, any attempt to cover the information requirement for in vitro genotoxicity mutagenicity with read-across or QSR models would be rejected. For relevant chemical species other than applied for entry, for example, substance constituents or non-intentionally added species, the information requirements for in vitro genotoxicity may be covered using general rules for adaptation, but this should be accompanied with a robust justification why it is technically not possible to perform the test with the relevant chemical species. In the example that we are going to share with you in our demo, I will provide an example how these general rules for adaptation could be applied for relevant chemical species other than applied for entry to cover for genotoxicity data. This is the table of content of Section 7, toxicological data. Here I would like to point your attention to the different type of documents that may need to be created while you are entering the information. For each information requirement, there should be at least one endpoint study record provided. The endpoint study record should provide relevant information, which must be reported in the form of a robust study summary. A robust study summary, it's a detailed summary that is aimed to provide sufficient information to allow for an independent assessment of the study and to minimize the need of the evaluator to consult with the full study report. Like a practical guide on how to report a robust study summary available at the link provided would give you more details on what type of information a robust study summary for a particular information requirements should include. Based on the information which is provided from the individual endpoint study records, you have to create a summary document, endpoint summary. I will provide a bit more information on the content of this document in my upcoming slides. Finally, under the general title, Toxicological Data, there are two summary documents that may need to be created. The first one, Summary on Genotoxicity Hazard document, always should be created. And the creation of the second summary document, Toxicological Information, depends on the conclusion on genotoxicity as well as on the availability of further data in the dossier. Here, I would like to provide a bit more details on the content of these two data summary documents. As I said, the first document should always be created because genotoxicity is an information requirement which is applicable for all migration tiers. Here you can see a screenshot of the template of the document, which is pretty simple, based on the information records for genotoxicity studies. Here you need to provide your conclusion on the genotoxicity hazard. The conclusion should be selected from a pick list. There are three options. If one of the two options, genotoxic or non-genotoxic with only genotoxicity data available, is selected, there is no need to create the second summary document. However, if the third option, non-genotoxic with data for other hazards available, is selected, that would mean that the relevant chemical species falls in the medium or high migration tier. And since it's not genotoxic, you have to identify the hazard for general population. The summary of the hazard for the general population should be recorded in the second summary document, Toxicological Information. In this document, first you need to identify the basis for a hazard assessment conclusion, and the basis should be selected from a pick list. The last option, non-hazard identified, which is highlighted here in red, it's not relevant under the context of the drinking water, even if the relevant chemical species doesn't show any hazard for repeated or reproductive toxicity. For the purpose of the MTC-TAP derivation and the risk acceptance, a DNEL should be derived. So in this case, and also in other cases, when DNEL is selected as a basis for hazard assessment, you also need to provide some background information for the calculation of the DNEL. This information would include the reference to the most sensitive endpoint, the point of departure, that could be a NOAEL, LOAEL, or benchmark dose, and the overall assessment factor, which is used for the DNEL calculation. If the option non-threshold effect is selected, it is expected to be based on carcinogenicity or endocrine disrupting properties. Genotoxicity, which you can see here also listed in brackets, it's not relevant under the drinking water context because we have this particular document that concludes on genotoxicity hazard. The information in the data summaries is based on the endpoint study summaries. As I mentioned, the endpoint study summaries should be generated under each relevant toxicological information requirement section in EUCLID. Here, the example is for repeated dose toxicity study. And this example would be further elaborated during our demo. Here, the screenshot just highlights the different parts of the template. The part which is crossed in red, justification for classification, is not relevant under the drinking water context because here we are not aiming to classify the substances. Section 2 should provide the rationale for the choice of the key study and the choice of the key value that is going to be used for the hazard assessment. Section 3 provides fields where the most relevant study or studies should be linked. Section 4, mode of action analysis, is not mandatory. However, providing information in this section could be particularly relevant for establishing the threshold versus non-threshold mode of action for properties such as endocrine disruption and carcinogenicity. Without a robust mode of action analysis, such properties would be considered as non-threshold, and this would result in an MTC tap of 0.1 microgram per liter that would be used for the risk acceptance. So far, my presentation focused on cases when toxicological data should be provided. As I mentioned a couple of times, there are situations when toxicological information does not need to be provided. This screenshot is just a reminder of the legal basis for this criteria that would lead to waiving of the toxicological information. These criteria include the availability of parametric value, MTC tab value, SML value, classification as CMR category 1A, 1B, ED, human health category 1, classification for environment PBT, VPVB, PMT, VPVM, as well as substances that are SVHC. Where and how to report the data waivers for the toxicological information. For the applied for entry, this waiver should be reported in the dossier header. Here you can see a screenshot of substance, organic material. The substance, the applied for entry itself has been identified as a relevant chemical species, and the waiving of the toxicological data is indicated in these two highlighted sections in red. So there is a question asking if the toxicological data has been waived, and if the answer is yes, then a justification from a pick list should be selected in the next question, and the pick list provides justifications that are listed based on section 1. When the toxicological information for the applied for entry being a relevant chemical species are waived, section 7 in EUCLID should be empty. Another example when section 7 in EUCLID should be empty is for applied for entry metallic materials. And this is not because the toxicological information is waived, but simply because the metallic materials are never relevant chemical species. This is what also Panos explained yesterday, but I think it's always good to repeat some of the most important parts to highlight them. So in this case, section 7, when the applied for entry is a metallic composition, should also be empty. For the metallic composition, the components of the composition, the metals, could be identified as relevant chemical species other than applied for entry. And for those, as well as for other relevant chemical species identified from organic materials or cementitious, they should be reported under section 1.5. And there in this template, together with the information on the migration level of the relevant chemical species, the toxicological data can also be waived. Exactly the same questions are asked if the toxicological data are waived, and the justification should be provided. If this is the case for the applied for entry other than, for the relevant chemical species other than applied for entry, in the separately created dataset for those relevant chemical species, section 7 should be empty. So also no toxicological information is expected to be reported. That was the more theoretical part of my presentation. I hope you find it useful and also helpful to follow a bit more easily the example case that we would like to share with you. The example case would cover organic material, and two relevant chemical species have been identified. The first one is the applied for entry itself, and the second one is the impurity other than applied for entry. So with this, I would like to share, if I can, just a second. Yes. Euclid. So what you would see is the place where we have created and listed different data sets. For our example, we have an applied for entry, which we entitled citric acid, for which we have created a data set, and then we have an impurity, ethanol, for which we have created a separate data set. So before I go into more details, I would like to make a disclaimer that the names of these substances are genuine. As you can see, citric acid and ethanol exist. However, the data that we used to fill our example are not for these substances. Some of the data are genuine, but some of them are modified. So basically, all these examples now have been developed for the training purposes. I hope you can see now the data set for the applied for entry. You can see that it's been created under the working context DVD application. In the dossier header, it is indicated the applied for entry has been identified as a relevant chemical species, and it falls in the medium migration tier. For medium migration tiers, the legal requirements for toxicological information cover information on genotoxicity, data to prove that the substance or the relevant chemical species doesn't accumulate in humans, information on repeated dose toxicity, and information for reproductive toxicity. For the purpose of this presentation, we are going to focus on information for genotoxicity and information for repeated dose toxicity. I would start with the information that should be provided for genotoxicity, mutagenicity. According to Table 1 of Annex 5 of Implementing Decision 365, the information for genotoxicity should cover in vitro mutagenicity study in bacteria, in vitro cytogenicity study that could be either micronucleus test or chromosomal aberration test. And if the results of these two studies are negative, then a third study, in vitro gene mutation study in mammalian cells, must be provided. So I've put myself into the shoes of an applicant and I have created and filled the information in my dossier. The information is filled under section 711, mutagenicity in vitro. And you can see that I have provided study record per each of these three information requirements. You may also notice that there are no entitled subsections for the three information requirements. So what would be advised when you are preparing your dossiers and the robust study summaries is to entitle the studies in a way that the study you are reporting is included in the title. For example, here, the study that I would like to give my example with is for in vitro gene mutation in bacteria, key experimental study. In the next part of my presentation, I would like to show you first what a good, robust study summary for an in vitro study means, what type of information should be provided, and to what detail of this information should be recorded. So this is the template of the so-called robust study summary that should be filled in Euclid. And it has different sections that are indicated here. The first section, administrative data, here you must fill the endpoint that you are reporting, the type of the information requirement, the adequacy of the study, also the reliability of the study. These are selected from a drop-down list from where you can pick up the relevant for you information. The section data source, it's also important. The section provides the reference to either the study report or the publication. For study report, there are certain information which must be provided, starting with the title of the report. You also need to have the year, the testing facility. The testing facility information is related further to the CLP laboratory if you report the study is performed according to CLP, and also the study report number, it's important to be filled. Materials and methods, it's another important section where you need to provide the guideline according which the study has been performed, information if the study was performed according to a GLP or not. The field of the test material, it's important. The way how the test material is reported would indicate its relationship and to what extent it resembles the relevant chemical species. For in vitro studies, the strains or the cell types under which the test was performed should also be reported. And this information also can be selected from a drop-down list from where you can pick the type of cell line or strains relevant for your study. Also, information related to the study design, the conditions, including metabolic activation, the type of the metabolic activation system also may be provided. Information on the test concentrations. There are also some fields where you can justify, for example, the selection of the highest concentration if it deviates from the concentration range which is recommended in the test guideline. Information on the vehicle, information on the positive and negative controls. So you can see that there is quite a bit of a detailed information that you have to provide. Most of this information can be selected from drop-down lists. However, there are also some free text fields where you can provide additional details. For example, this field called details on test system and experimental conditions. Here you can provide information on the dose range finding studies or concentration finding studies. If you deviate from a guideline here, you can provide the type of deviation and also justify the deviation. How much information you can provide in these free text fields would depend on the type of the study that you are reporting and also all the information available. But in general, the more details you provide, the better, because this would help the evaluator to perform their independent assessment. Most of those drop-down fields that I went through are also mandatory. They are not marked as mandatory. However, you would find it out when you validate your data set. So this is the validation button, and there would be a short presentation afterwards on the validation assistant, how this could be used. So while you are validating your data set, if you skip some of those so-called mandatory fields, or if the information provided there is not sufficient, the validation assistant would give you a failure message, and in this message it would be indicated what is the problem and how the problem could be fixed. So if this happens, then you have to go back to your data set, to this template particularly, and correct or fill the missed information. This is quite important because this validation assistant would help you to submit dossier with at least minimum information that must be reported. Going down to the other sections, there is also a place where the evaluation criterion could be listed. And we go to the section results and discussion. Section results and discussion, when it comes to experimental data, it's one of the most important sections. Because it reports the results and also the final conclusion. For in vitro studies, the results are first given in these tables where you can add rows, and you have to provide a conclusion on genotoxicity for each condition with and without metabolic activation for the different strains. You also need to provide information on cytotoxicity. The cytotoxicity conclusion as well as genotoxicity conclusion can be selected from a drop-down list. For cytogenicity, together with the selected from the pick list outcome, you could also provide some explanation in the free text field under. As you can see, these tables, they provide just the final outcome of the study. And this final outcome that for genotoxicity could be negative, positive, or ambiguous should be substantiated with individual results provided in tabulated form. Tabulated results are part of the robust study summaries, and they're really important because this would help the evaluator to make their independent assessment and to evaluate if your conclusion is correct or not. The tabulated results could be provided in two places. The first one, they could be embedded in the template itself. There is this free text field, overall remarks, where text plus tables could be added. The tables could also be pasted here from a document that you have somewhere else. You could also create the table here as well. The tabulated results, together with the full study report, if you have it available, could also be attached here in this field. You can see that there are two types of attachments that you may provide. The one is called confidential document, and the other one is sanitized document. We would strongly advise you to attach sanitized documents because under the drinking water provisions, the information which is reported in EUCLID would be also publicly available with some exceptions. But when it comes to attached documents would also be publicly available. So it's very important you to provide information which doesn't contain confidential data. Finally, conclusion and executive summary should also be provided. So this is a good robust study summary, which is for in vitro study. I would also like to share with you an example of a robust study summary for an in vitro study that may be considered as insufficient by the evaluator. So me as an applicant, let's say that I have provided the minimum and even more than the minimum information for the fields data source, materials and methods. However, when we go down to results and discussion, this is the only information on the results that I have decided to record. This is just the final conclusion stating that the relevant chemical species is negative with and without metabolic activation on the tested strain. This conclusion is not substantiated with any further explanation, tabulated data, neither embedded nor attached. So if the evaluator looks at this robust study summary, he or she would not be able to make their independent assessment on the results, particularly because they do not have the tabulated results to conclude that indeed the substance is non-genotoxic. Because of the lack of this information, the conclusion of the evaluator for genotoxicity in general, the hazard of genotoxicity, would be that the information is insufficient to exclude that the relevant chemical species is not clastogenic, in this case because the example is for chromosomal aberration test. And this would lead to an MTC-TAP of 0.1 microgram per liter. You can imagine that for substance that falls in the medium or high migration tier, the MTC-TAP of 0.1 would automatically result in failure of risk acceptance because MTC-TAP would be much lower than C-TAP. So the take-home message here is when you report the toxicological information, please follow the requirements under the robust study summary. Also, consult our guidance and provide as much details as possible in order to avoid some unpleasant conclusions. For the third information requirement, I'm not going to go into detail. It follows exactly the same requirements for a robust study summary for an in vitro study. This is in vitro gene mutation study in mammalian cells. Quite some information is provided, and here also the results are embedded in the template. Here you can see that this template can accept more than one tables and also some text in between. Based on this information from the three in vitro studies, the next step would be to create the summary document for mutagenicity, where you have to indicate the final conclusion on genotoxicity and also to link the relevant study records. So basically, these study records linked here are those study records that are entered under section 711. And the conclusion is no adverse effect or the substance, the relevant chemical species is negative. And finally, this should be reflected in the summary document on genotoxicity hazard. In this document, this template that I already showed in the screenshot, but this is how it looks in EUCLID. There is the link to the summary of mutagenicity and the conclusion selected from a pick list, in this case non-genotoxic, with data for other hazards available, because the substance falls in the medium migration tier. So having said that, I would now give the floor to my colleague Hilary, who would lead you through the information requirements for repeated dose toxicity.
Thank you, Vesela, and good morning, everyone. No, sorry, it's actually afternoon already. Afternoon, everyone. My name is Hilary Tarva, and I'm a regulatory officer in the Drinking Water Directive team. In the next part, I will walk you through how to complete a repeated dose toxicity study record in EUCLID section 7.3, focusing on the key fields, common pitfalls, and good practices. The repeated dose toxicity information requirement is set out in Annex 5 of the Implementing Decision 365 of 2024, specifically in the points 7.2 and 8.2 of the tables 2 and 3, depending on the migration tier. I will briefly explain what information should be entered in the main parts of the record, and also highlight what assessors usually look for when reviewing it. Repeated dose toxicity studies are important because they help us identify systemic effects, target organs, and the basis for deriving DNLs. Repeated dose toxicity Repeated dose toxicity studies may also examine parameters that have the potential to identify specific manifestations of toxicity, such as neurotoxicity, immunotoxicity, endocrine-mediated effects, reproductive toxicity, and carcinogenicity. Repeated dose toxicity studies also help assessors understand which findings are most relevant for the hazard and risk assessment. For that reason, high data quality and structured reporting in EUCLID are essential for regulatory evaluation. In the interest of time, I've pre-filled the fields, and please note that the data shown here is entirely fictional and used only for training purposes. The first three sections are similar to those already presented by Vesela for genotoxicity, but let's get started with the administrative data section. The key fields here include the endpoint, the type of information, and the adequacy of the study. Reliability is expressed using the Clemish score, and it is important to provide a clear justification for the score assigned. In practice, this means selecting an appropriate options in the structured fields and making sure the justification clearly explains why the study is considered reliable, reliable with restrictions, or not reliable. If the study has limitations, these should be mentioned briefly and transparently here. You can also include attachment and cross-references in these sections where relevant. In the data source section, you should provide the reference for the study and indicate how the data were accessed. The materials and methods section should be described in a comprehensive way. This includes information on the study design and the test material, as well as the test animals. When completing this part in Euclid, it's best to use the structured fields as far as possible and then use the free text boxes only for essential clarification that does not fit elsewhere. You should start by indicating the guideline followed, and any deviation should be clearly documented. It is important not only to name the guideline, but also to explain whether the study complies fully with it. Even minor deviations should be reported and briefly assessed for their impact on the study quality. This point is often overlooked, but sometimes assessors pay close attention to. You should then describe the test material, making sure it's correctly linked to the substance data information on purity, impurities, and physical form is consistent with the substance dataset. This is important because inconsistencies between the study record and the substance identity can create uncertainty during the evaluation. Next, describe the test animals, including species, strain, sex, age, weight, and the number of animals per group, as well as details on the environmental conditions. These details should be entered in the corresponding Euclid fields so that the study design can be easily understood and compared across records. Clear and complete reporting here also makes it easier to judge whether the study is suitable for regulatory use. You also need to describe the exposure conditions clearly. In particular, it is important to report the dose levels in a way that supports the identification of effect levels later on, and to describe the control group and any vehicle used. If the dose levels are not clearly reported, it becomes much more difficult to understand the basis for the NOAEL and LOAEL. In addition, you should explain how the substance was administered, for example, by gavage or via the diet, and describe the observations made during the study. These include clinical observations, body weight, food consumption, and any functional or behavioral assessment where relevant. As a practical point, it's useful to ask whether another assessor could understand how the study was conducted from the Euclid record alone. I will now move on to the results and discussion section, which is where the key findings of the study need to be presented clearly and interpreted. Here, the results should be entered in a structured way using Euclid fields rather than relying on the free text. You should report mortality, clinical signs, body weight changes, and any observed effects on organs or tissues, including histopathological findings. A good approach is to enter each key result in the most relevant field first, and then use the free text fields to explain the overall pattern of findings and any study-specific considerations. This usually makes the record clearer and easier to evaluate. A critical element is the identification of effect levels. You need to report the NOAEL and, where relevant, the LOAEL clearly, including the value, units, and basis for the effect. For example, you might report a NOAEL of 150 milligrams per kilogram body weight per day based on histopathological effects in the GI tract, liver, and spleen. The important point is that the selected effect level should be clearly linked to the findings described in the study. You should also identify the target organs and distinguish between treatment-related effects and incidental findings. It is important to provide your own interpretation rather than simply reproducing the study report. This is particularly helpful where the raw data study findings are extensive and the regulatory relevance needs to be made clear. The applicant's summary and conclusions is particularly important, as it is often the first section read by the assessors. It should provide a concise summary of the study, the key findings, and clear regulatory conclusion. In other words, this part should not simply repeat the study report, but should explain what the study shows, which findings drive the conclusion, and why the study is relevant for the hazard assessment. To conclude this part, it is essential to use Euclid structured fields correctly, provide clear justifications and interpretations, and ensure consistency across the dossier. Particular attention should be given to the effect levels, target organs, and study reliability. I would also recommend running the validation feature while filling in the dossier, just to check that all the relevant fields have been completed. A well-prepared study record significantly improves data quality and helps to facilitate the evaluation process. Next, I'll move on to the endpoint summary. You can recognize it by the small Greek sigma symbol. At endpoint level, the purpose of the endpoint summary is to identify and justify the key study or studies that will be used for further assessment. It should therefore present in a very concise way the most relevant and reliable information. Since the Euclid template is based on the OECD harmonized template, you will also see other routes of exposure mentioned here. However, in the Drinking Water Directive context, only the oral route is relevant. In this example case, you will find the study under the subchronic toxicity study when you scroll down in this field. If only one study is available, the summary can focus on the main highlights of that study. And if several studies are available, it should briefly explain why one study or particular set of results is considered the most suitable as key data. In this example, I have linked the study record I presented earlier and included it under the relevant section for subchronic toxicity. Now we can imagine that we have now completed all the sections needed for the toxicological information for the applied for entry, and I'll move on to the toxicological information summary section. This section must be created for relevant chemical species in the medium and high migration tiers that are concluded to be non-genotoxic. It is important to note that the option "no hazard identified" is not applicable in the Drinking Water Directive application. Even if no effects are observed at the limit dose, hazard assessment for threshold effects is still required, and a DNO must be derived. This DNO is then used to calculate the MTC tap value. When DNO is selected as the basis for hazard assessment, you need to provide a summary of the information used for its derivation. This should be based on the most critical dose descriptor, typically the lowest relevant NOEL or LOEL value for oral route and the relevant type of effect. For further details, you can consult the ECHA guidance on Drinking Water Directive Volume 2, as well as Chapter R8 of the ECHA guidance on information requirements and chemical safety assessment. If non-threshold effects, such as carcinogenicity or endocrine disruption, are used as the basis for hazard assessment, only specific fields are relevant, including the most sensitive endpoint and the route of original study. If non-threshold effects, these can be reported at the bottom of this section. That's it from me. Thank you very much for your attention. Back to you, Vesela.
Thank you. Thank you very much, Hilary. So That was for the applied for entry in relation to toxicological information. I would like to continue now with the other relevant chemical species other than applied for entry. As we mentioned at the beginning, we have identified one impurity as a relevant chemical species. And for it, we have created a study record under section 1.5. In this template that we have developed under section 1.5, we recorded the migration tier for this impurity. The impurity falls in the low migration tier, and you can see that the toxicological information has not been waived. The important part of this template is the link to the dataset of this impurity that has been separately created. And now by clicking on this link, I would go to the dataset that we have created for ethanol. So you can see that the dataset was created under the working context DWD data for a relevant chemical species. The table of content here is much shorter when compared to the table of content for the applied for entry. However, when we expand section 7, toxicological data, the information requirements and the layout of this section, it's exactly the same as for the applied for entry. For relevant chemical species following under the low migration tier, only genotoxicity information must be provided. So now I would like to share with you the example how the information requirement for in vitro genotoxicity for a relevant chemical species other than applied for entry could be adapted using general rules for adaptation. The example that I have created is for read across. First, I would like to note that independently of the information requirement for which read across is used, always two study records should be created for the information requirement which is covered by read across. The first study record is for the target substance, and the second study record is for the source substance. I would first go through the template for the target substance and to show you what is the difference between the templates or the so-called robust study summaries of the target and the source substance. For the target substance, the endpoint is in vitro gene mutation study in mammalian cells that I selected to be adapted. The type of information is the important field here. Since there is no data on the target substance, and the information would be covered with an analog substance, the type of information should be indicated as read across. This is selected from a drop-down list, and there is also a possibility to select category approach if grouping of substances is used as an adaptation. For this example, I've selected analog substances. So having selected the type of information and indicated as read across, this would trigger the need of two justification documents to be provided. The first justification is to identify and to clarify why it is technically not possible to perform the test with the relevant chemical species. And the second justification is for read across approach itself. There is this free text field where you can provide some high-level information on this. There is also a possibility to insert existing template this is what I did for inserting the template that provides the structure that should follow the justification for read across. These justifications that or information, high-level information provided in this free text field should be substantiated with relevant documentation. And it is advised this documentation to be provided as an attachment. So there is this attached justification field where you can attach the relevant documentation. You can see here, because there need to be two justifications in this case, there are two documents attached. The first one, why it's technically not possible to perform, and the second one for the read across. These justification documents would also be looked at by RAC rapporteurs, by the evaluators, and if these documents are missing or if they do not provide sufficient information, this may lead to rejection of the read across adaptation that would result in a data gap for the information requirement in question. Another important field in this template of the target substance is the cross-reference field, where the applicant should provide the link to the source study. So basically, this is the link of the data entry created for the source study. Even if there is no information for this information requirement on the target substance, the template would still require some minimum information to be filled, particularly on the test guideline. Also the test material here, because this is the target substance, you can indicate the target substance as a test material, and this would indicate that the information would be read across to this substance. Then some information on the strains also should be provided. However, you can see that this robust study summary template is pretty empty. There is also no need to provide any details on the results, because all this information should come from the robust study summary of the source study. And the robust study summary of the source study follows exactly the same provisions for robust study summaries for the target substance. So there are no differences in that. And I'm not going to go into detail because I've already showed you what a good robust study summary for an in vitro study should cover. So all information related to the materials, methods, test material. The test material here is the analog substance, of course. Details on the results and also tables provided in the free text field. So this is the way how the read across should be reported when it's used to cover for in vitro genotoxicity studies for relevant chemical species other than applied for entry. Similarly, for QSR models, however, there shouldn't be two separate study records. Only one study record would be sufficient. There should be a justification, again, explaining why it's technically not possible to perform the test, and also documentation for the model and the prediction. So QMRF and QPRF reports could be also attached. Finally, I would like to provide you an example how specific rules for adaptation according to column 2 could be used. These adaptations could be used for both working contexts, so there's no difference here. The example that I have developed, it's for mutagenicity in vitro micronucleus test. And when column 2 adaptation is used, this should be indicated in the data waiving field. So when column 2 adaptation is used, very often the data waiving is based on studies scientifically not necessary or other information available, and this is selected from a pick list. Together with this data waiver, justification for the data waiving must be provided. And the only legal basis to waive the in vitro micronucleus test or chromosomal aberration study is when there is a relevant in vivo study available. I would like, however, to expand a bit the drop-down list, because this is what you would see when you start filling the information if you are waiving the study according to column 2. You would see also some justifications for waiving the chromosomal aberration or micronucleus test. Please note that these justifications are not legally relevant for the Drinking Water Directive. This is an OECD harmonized template that cannot be tailor-made only for the drinking water, and these are justifications that are relevant for other frameworks, particularly REACH. So the advice here is when you are selecting the type of justification, if you use column 2 adaptation, please read carefully and select the relevant for the drinking water one. If you by mistake select something else which is not relevant under the drinking water, unfortunately the validation assistant would not alert you about it, because the validation assistant would check if the field is filled but not the content of the justification. So if you by mistake, as I said, selected a wrong justification and you didn't identify this before you submit the dossier, for sure this mistake would be identified by the evaluator, and that may lead to a conclusion that you have used not legally based justification, with certain consequences of this. So if you have used column 2 adaptation and waived the in vitro study based on an in vivo study, this would mean that the in vivo study should also be reported, and it should be reported under section 712, mutagenicity in vivo. It is important to note here that you have to provide a relevant study to cover for the information requirement in vitro. You cannot just provide any in vivo study. For example, in this case, since the information to cover would be for in vitro micronucleus test, the relevant in vivo study is in vivo erythrocyte micronucleus test or bone marrow test or chromosomal aberration test. The type of the study can be selected from a drop-down list. An example of a study that it's not relevant to cover for the information requirement micronucleus test would be, for example, in vivo mammalian cell DNA damage or repair. So to note here is the relevant study should be provided, not any type of in vivo study. I'm not going to go into detail on the robust study summary here because it follows the similar requirements. You have to have information on the guideline, the test material, because it's an in vivo study, test animals, the sex, the route of administration, also the doses that have been administered. You also need to provide some details on toxicity and also the tabulated results. So based on all this information that it's reported in vitro and in vivo, the mutagenicity summary document is created, and it's a bit longer because it covers information for in vitro, the studies, and also the conclusion from in vitro study and the information and the conclusion from the in vivo study. In both in vitro and in vivo, the relevant chemical species was identified to be non-genotoxic, which is reflected in the final genotoxicity hazard summary document with the conclusion the relevant chemical species is non-genotoxic with only genotoxicity data available. So that was the end of my presentation. I hope that it was useful. We are happy to take any questions during the Q&A session later today. And with this, I would like to thank you for your attention. And now I would give the floor to my colleague Panos that would continue with the presentation. And while we are exchanging places, I'm going to freeze the presentation and also switching the camera off.
Thank you. Apologies for being a little bit slow. We're trying to switch places and get ourselves ready for the next part, which should be section 8, the risk acceptance section of Euclid. If you give me 1 second to prepare for first to open my little data set. I know the screen is paused, but yes, now I will try to move to the presentation. Hopefully it will work. Yes, I need to click on that. And right, okay, risk acceptance. So let's make a start on the risk acceptance. This is the final demonstration of the day. Before we move to the demonstration, there will be a few slides just to give you a flavor of what the section 8 is supposed to look like, especially when you open for the first time. And section 8 corresponds to Annex 6 to implement decision 365 of 2024. And the requirements, you need to be aware, they do differ when it comes to risk acceptance between metallic materials and all other the other three material types. Now, the key elements of section 8 is that you need to explain the methodology you have followed in doing your risk acceptance for the relevant chemical species. The second element is you need to provide a CTAP value, and there are some variation that I will come to this when I will be presenting to you how to do it for metallic compositions. You need to identify and justify and explain how you have come up with the empty CTAP value, the migration limit value for the specific relevant chemical species. And finally, you need to make a comparison between the CTAP value and the empty CTAP value. The ratio of CTAP over empty CTAP is called the risk characterization ratio. Sometimes we call it in short RCR, but it's effectively a ratio of CTAP over empty CTAP. And as an applicant, you should aim to show that this is below 1 for every relevant chemical species. Now, there is relevant guidance on how to prepare this section 8 of Euclid. The guidance, the technical and scientific guidance, is in the second volume of our Drinking Water Directive guidance, and specifically in its chapter 6. But of course, if you want to understand how you generate the setup value and the empty setup values and so forth, then you need to be aware of other chapters as well, 3, 4, and 5 of this guidance volume 2. And you can see on the slide as well the direct link to that guidance document. Now, there are some exceptional cases that we will touch upon in the live demonstration where you do not really have relevant chemical species. And one example that was actually presented yesterday is metallic compositions which are demonstrated to be passive. In that case, you do an electrochemical test and you do not have relevant chemical species, you don't have a release of specific elements from the metallic composition for which you need to have CTAP and empty CTAP values. Okay, so when you open section 8 for the first time, this is empty. Obviously, I try to split it into 2 parts to make it fit into the slide. There are the first part, the upper part is the one marked with 1 on the left-hand side, and then the number 2 follows. You will see that there are quite a few fields. There is only one field which is currently is mandatory to fill in, and this is the material type. And it has a very important purpose because it really activates the dynamic content rules, which may change the fields you see later on. And the specific change that you need to be aware of is that in the type of when you choose material type metallic materials, then the field type of metallic composition is activated and you need to make a choice out of 3 options, and I will show this in practice in a moment. So please be aware that the material type at the very beginning of the document is a very important field that, of course, it is mandatory, and you need again to make the right choice because, as I mentioned at the beginning of our event yesterday, this material type many times is being requested for you to input it, and of course, we hope that everybody will do it consistently in all parts of the ECHA dossier. The screen came back. Now, there are a couple of important points to be aware of about Section 8. Section 8 covers all relevant chemical species, including the applied for entry, if it is a relevant chemical species itself, of course. So imagine you have an application where you have your starting substance and 2 impurities, let's say. You remember that the 2 impurities have their own datasets linked in Section 1.5 of the main dataset. However, in Section 8 of the main dataset, all 3 relevant chemical species, the starting substance and the 2 impurities, need to be presented. Also, remember that in the latest version of EUCLID, the one that was released at the end of April, every relevant chemical species requires its own document, its own record. Previously, that was not, you could deviate from that rule, but now you must follow it like this. So in my example, again, one starting substance with 2 impurities, it means you need to create 3 documents in Section 8 to cover each one of these relevant chemical species. Now I will go to the live demonstration. If I manage to, this doesn't work. I managed to get this here. Okay. Right. I will try to zoom in a little bit. Maybe that will help. Okay. This is obviously a dataset which has been specifically created for training. I have only created very few records. You can see the number of the records in each section. By the way, we have not mentioned this. Maybe it is obvious. This number 1 you see near the Section 1 general information is there's 1 record there. In Section 5, there is also 1 record. I can open just to show you what I'm referring to. There's just a record for a fake alloy. And then in Section 8, I have 5 records. Now, the 5 records have been created for training. As it happened before, I'm trying to cover different material types, and that's why I'm having this variety. But in a real application, there's only 1 material type to be covered in a single application. When it comes to different material types, organic and cementitious are more or less identical. Actually, probably I should say identical in the way we do the risk acceptance of the relevant chemical species. In the case of inorganic materials, enamel, ceramics, other inorganic compositions, they are generally following the organic and cementitious approach. There's only one field where you need to identify the type of relevant chemical species, and then the pick list is different because you have to choose only between effectively constituent or impurity, which is not the case for organic and cementitious. And then we have the metallic materials, which are, as already I have mentioned, they are really different, so they need to follow their own route. Let's take a look at the first risk acceptance document. In my example, I have filled in the fields, but I can go through them to explain how I have made all these choices of the different options. The material type, it is at the beginning. There is a pick list of 4 options. I have chosen organic materials. And now I imagine, in this case, it's an imaginary example, obviously, that my relevant chemical species is called workshop substance 1. It's obviously very, very slim reference substance. It doesn't have an EC number, CAS number. It's not really important for the purpose of this demonstration, but I do have a chemical species name, which is workshop substance 1. And in my imaginary case, it is the substance, it is a starting substance, which is an additive. Okay, so taking this scenario into account, under the field relevant chemical species type, I need to choose from a pick list the correct option. This is a nested pick list. So if I click on this blue button, I can see 2 main options applied for entry or denials. I will expand them by clicking on these little arrows, both of them, to see all the different options. And in my example, as I explained, I assume that this is a starting substance. So it is an applied for entry, but it's not a monomer, it is an additive. So the correct option for me, in my example, is the one up here. I click it and it is selected like I had done in the past. Now, there's always the remark field where I can add something, and just to demonstrate how I can type something, although I don't think this will be necessary in the vast majority of cases. Now, let's go to the MTC tab value. This is a field which is a numerical field. You need to put only a number. It doesn't take any words. It's just a number with a migration limit value. Now, in my scenario, just to create a little bit of a context, I assume that the migration is in the low migration tier. So the setup value, the concentration of the tab, is below 2.5 micrograms per liter. I assume that the applicant has provided genotoxicity data, and the substance is concluded by the applicant not to be genotoxic. And we don't have any other genotoxicity information available. So low migration tier, only genotoxicity data required, and the applicant has only given genotoxicity data, and the conclusion of the applicant is that the substance, it is not genotoxic. Okay, so what happens here is that with only genotoxicity data, the conclusions are default. Either the substance can be shown not to be genotoxic, and you end up with an empty setup value of 2.5 micrograms per liter, or if you cannot demonstrate, if you cannot exclude genotoxicity, or if the substance is conclusively genotoxic anyway, then you go to a default empty setup value of 0.1 micrograms per liter. These default conclusions are shown in Annex 6 to implementing decision 365 of 2024. In my example, I have genotoxicity data. The applicant says it is not genotoxic. I end up with a default value of 2.5. Now, the next field is what is the basis for selecting an empty setup value? And this is, again, a nested pick list. And you need to pay careful attention here to ensure that you choose the correct option. The correct option is the one you see down here in the gray panel, but I will try to go through all of them just to demonstrate the variety of options that are out there. Okay, so I will start from clicking the blue box. There are a number of options, and we can see step by step which one I should be selecting. The top 2 ones are referring to the limited assessment approach. Limited assessment approach refers to section 1 of Annex 6 to decision 365 of 2024, where you do not provide toxicological information as an applicant, and you follow this limited methodology because there is, for example, a parametric value or a valid specific migration limit, or you have some a valid MTC tab or some other information. You have a severe hazard that is recognized, so you don't need to provide tox data. You go to some default conclusion. So these are not relevant to my example, because in my example, the applicant has provided tox data with the genotoxicity data to reach some conclusion on the MTC tab value. Okay, the bottom one is also not relevant because it says it's we're dealing with an MTC tab, which is based on the standard assessment approach. Yes, we did follow the standard assessment approach with tox data, but we did not calculate an MTC tab value. We ended up with a default conclusion, and I explained we have only genotoxicity data. Either it is not genotoxic and you give 2.5, or if you cannot show that it is not genotoxic, you end up with 0.1. So the correct option is the third one from the top. And then there are more options to go through. It will take us some time to go through, but let's try. We are not dealing with a non-threshold effect, which is the first sub-option up here. Let me put my little hand to highlight it. Then the second option is that we have a case where we cannot allow the data that we have in our hands do not allow the exclusion of genotoxicity. This is not our case because the data we have helped us as an applicant, now I'm speaking, to conclude that the substance is not genotoxic. Okay. The third option, the relevant chemical species is accompanied by toxicological data that allow the exclusion of genotoxicity but do not allow for a conclusion on other effects. This is relevant to a relevant chemical species that has that migrates in the medium or high migration tier, and we do have additional data, but we cannot conclude on those specific additional data which correspond to the medium and the high migration tier. So by exclusion, you end up with the correct option being the bottom one, the fourth sub-option, where we have clearly negative results from the perspective of the applicant, of course, for genotoxicity/mutagenicity, and no other toxicity data that show hazard that leads to a value lower to 2.5 microns per liter. This need to be read carefully because it may be cryptic from the beginning. We tried with the different options here to try to cover all potential possibilities, and perhaps the wording needs some improvement, and we're very happy to receive feedback to make sure that these options perhaps become a little bit more transparent. But here, in this example, genotoxicity data, it is not genotoxic, default value 2.5, I select this one. The next one is the justification of the derivation of the MTC tab value. In a case like this, and this is a free text field that you can start typing in your own words using your keyboard, you don't really need to write too much extra information, but simply to explain what is the situation, and this is what I have tried to do. So I'm just I make reference to section 7 to what I have presented with my genotoxicity data. I explained that the relevant chemical species migrates in the low migration tier, and genotoxicity information has been provided in section 7.1. That information conclusively demonstrates that the relevant chemical species is not genotoxic. No further information is available on any non-threshold effect, e.g. carcinogenicity or endocrine disruption for human health, that is relevant to the substance. Something as simple as that, which obviously just summarizes what I have been explaining to you for the last couple of minutes. Okay, we can move on. The MTC tab total and remarks on it is not relevant to our case. You need to be aware that there are substances listed in the European positive list, in particularly in the reference to table 3 of Annex 1 of Decision 367 of 2024, where there are MTC tab total values for groups of substances. And these are relevant to an example that is coming, the third example, the third record under this section 8 of Euclid, that I will touch upon there. In this specific example, we don't have an MTC tab total, we have a random substance that has its own MTC tab value specifically dedicated to it. So these two fields can be left empty. Now, the next field is about the TOC criterion. there is this is a pick list to choose from: yes, no, or not relevant. The TOC criterion is relevant to organic substances which migrate in the high migration tier. And further details, because we will not have the time to go through this in detail, but further details on whether you need to be concerned about the TOC criterion can be found in our guidance document volume 2 in section 6.3.3. Here I have a relevant chemical species which migrates in the low migration tier, and I don't have to consider this TOC criterion at all. So I'm using as the option not relevant. The next field, I'm coming now to the end, is the CTAP value that comes from the migration assessment, either ideally physical migration testing or modeling, if it is justified. I provide the value, again, it's a numerical field. I can only give a value 0.25, and then I just divide the 0.25 of the CTAP with the 2.5 of the empty CTAP. I end up with a risk characterization ratio of 0.1. Okay, of course, I have chosen easy numbers to make my calculation very easy. But this is basically it. Material type, you need to provide a link to the reference substance. This is not a data set here, this is a reference substance. You need to explain what is the relevant chemical species type, the empty CTAP value, and what is the basis how you have ended up with this. You can ignore the empty CTAP total if it's not relevant to you, the same with the TOC criterion, CTAP value, RCR, risk characterization ratio, and this is it. This is obviously one relevant chemical species. My application may have 2, 3, 5, 10, so I need to create 2, 3, 5, 10 documents to follow the same approach for each one of them. Now, I will move to the next example. Yes, I will leave, I will not save. The next example is where I have still an organic material. I could have a cementitious material, it's not really that important. Now I have a substance which is used as a monomer, is a starting substance, and it is actually has a classification as carcinogen category 1B. Okay, so again, from the material type menu, the pick list, actually, I use the organic materials. I could use cementitious. It's equally good for the purpose of demonstrating. I make the link to the reference substance, this made up workshop substance 2. And then I need to choose from the nested pick list the correct option. I will go through that again just to show you. As I said, it is an applied for entry, is a starting substance, or organic cementitious constituents, since now we're talking about organic materials. So the applied for entry is a monomer. As I explained, I treat this as a monomer that has severe hazard. So I choose that. And then the empty CTAP value is 0.1. Now, where is this 0.1 coming from? This comes from section 1 of Annex 6 of Decision 365 of 2024, where it is explained that where we have a relevant chemical species which has a severe classification like CMR category 1A or 1B, or AD, endocrine disruption for human health category 1, or is a PMT, VPVM, PBT, VPVB, or is a SVHC for human health endpoints, then there is the default conclusion on the empty CTAP value, which should be 0.1 micrograms per liter, unless that specific relevant chemical species has a parametric value, and then you use the parametric value as the basis for creating the empty CTAP value. In my example here, to keep it a little bit simple, I assume that this fake substance does not have a parametric value in Annex 1 of the Drinking Water Directive, so the default conclusion is 0.1 micrograms per liter, and this is what I have typed in this field, empty CTAP. Okay, now the basis for selecting the empty CTAP value will go again through the nested pick list. Here we have different options to consider because we did follow the limit assessment approach. For a substance like this that has a classification as CMR1A, 1B, there is no need, no requirement for tox data. So there is no tox data, imagine, in this dossier. for this relevant chemical species. So I have followed the limit assessment approach, and the obviously correct option is the top one because I am relying on a known severe hazard. So if I extend that first option with the different sub-options, you can see the different options with the CMRs, the EDs, PBTs, and so forth. The correct one in my example is, as it is a carcinogen, I select the very top one. Okay, this is just an option from a pick list. There is now also a justification for the derivation of the MTC tab value. Here, I don't have to say too much more that I have explained. Perhaps here I would have to explain in more detail if there was a parametric value, and in order to get from the parametric value to the MTC tab value, you need to apply an allocation factor. And if we will come to that in a moment in the fourth example in this section, the allocation factor is explained in section 6.4 of volume 2 of our guidance. So here I'm simply summarizing what I have already explained. I am saying that this is a default MTC tab value of 0.1 micrograms per liter due to the classification of the substance as a carcinogen category 1B and the absence of a parametric value for it. See section 1.1 Annex 6 to Commission Implementing Decision EU 365 of 2024. So you can keep it short if it's already very, very obvious what is the basis, but in some cases you do need to explain. And I think that I have an example for zinc that is coming up, and there you do need actually to write some information to explain. Again, in my example, I don't have MTC tab total. The same thing with the TOC criterion. I assume it is in the low migration tier, and it should be in the low migration tier because my MTC tab value is obviously very low. It is a carcinogen 1B, so the MTC tab is already very low at 0.1. And if my migration, the CTAB was higher than 0.1, I could not show acceptable risk. So I skip the TOC criterion as well. The residual concentration. Now, this is a field that appears when you have previously selected that there is an issue with classification. And classification, or we have a severe hazard to be more inclusive, because there is an additional risk acceptance criterion for substances which do have these severe hazards. Not only do they need to be monomers or niaces, so you cannot have an additive which has a severe hazard and to list it in the European positive list. This is not accepted. It must be a monomer or to be a non-intentionally added species or a substance constituent. And also it needs to be meeting a requirement on the residual concentration of that relevant chemical species in the material. And there are two sub-options here. Either it is, and I will show you from the pick list because you need to choose, I have chosen 0.02, but the pick list is either it is below 0.1% weight by weight in the material, or where we have measurement uncertainties for the migration estimation, then you need to meet even a lower concentration, residual concentration in the material. And in my example, I assume that I do have measurement uncertainties. That's why I must meet the lower threshold of 0.02% presence of this relevant chemical species in the material. So I select from the pick list the 0.02 as I had done already. Now there is some field for justification. I did not come up with something very profound, I must say. I just wrote a small sentence, which is there are uncertainties in the measurement of the relevant chemical species in the migration water as explained in section 5.1. Okay, you may need to explain a little bit in more detail what those uncertainties are. I wasn't able to come up with a very plausible or realistic scenario. But please do not underestimate the need to provide some justification why you select 0.02 or 0.1. Here, there is a possibility to attach a document. I have attached a document called Residual Concentration Analysis. Obviously, it's a fake document. I will not open it because it doesn't have any relevant contents. By clicking it, I managed also to download, which is not what I expected. But yeah, this is just to show you that by clicking just next to the attached document field, you can open it, you can see it. I can click the little cross to remove it. I can attach a new document and so forth. But only one document is required here to explain if you have made any analysis to show what is actually the presence of this relevant chemical species in the material. And to finish, I have a setup value, which is, as you can see, quite low, very conveniently. I divide this by the empty setup of 0.1, and I end up with an RCR value of 0.33, which is below 1. So I have shown risk acceptance. The final one for the organic slash cementitious materials, I will leave, I will not save. It's just to show how to use the empty setup total value. Again, it's a made up example. Material type is organic materials. My relevant chemical species is this acrylic acid ester, and it is a monomer. So I will not show you again the nested pick list how I go into the monomer option for the applied for entry. I skip the empty setup, and still I need to provide the basis for selecting the empty setup value. I will not go through this because it depends on my scenario. It doesn't matter, I can make something up, but you do need to go through this nested pick list to explain what is the base of your empty setup value. And there is a justification to explain, obviously, that as I have shown in section 7, through this my toxicological assessment, the correct value is whatever it is. And now in this case, I selected this acrylic acid ester specifically because there is an empty setup value, of course, in Annex, in Table 3 of Annex 1 to Decision 367 of 2024. And this is entry 21 in this table, where there is an empty setup total, which is 300 micrograms per liter expressed as acrylic acid. Okay, and I have added this because this is no longer a number field. It's something that you can write text as well. Previously, for the empty setup value, this field I cannot write in text. I'm typing, trying to press something on my keyboard, but it's not a number, so I cannot type it. Here I can write 300, expresses acrylic acid. I can add some remarks on the empty setup total underneath to explain that yes, I'm confirming what is shown in entry 21. The TOC criterion doesn't apply to me in this case. I have a setup value, an RCR. So basically, if there is an empty setup total, I just use the two fields that I saw earlier, and I have left empty because they were not relevant to those specific cases. So nothing too sophisticated, just you need to be aware if your substance does fall under these cases where there is an empty setup total. And I do suggest that you take a look at Table 3 in Annex 1 of the European Positive List decision, because this will give you an idea whether this empty setup total concept applies to your substance. Now let's move to something different. Let's move to the metallic compositions. I will not save my work. So I make the choice of metallic materials as the material type. When I choose this, I need to choose it again. The type of metallic composition appears. Previously, we didn't see this field in the three previous examples that were for organic or cementitious materials. And I need to make a choice out of three options here. The pick list has passive metallic composition. There is an example coming up later on, so you will see what happens when I choose that. The second is a metallic composition exclusively used for product group D, so very, very small components where they have a negligible contact surface with the drinking water. And the last one, which we expect it to be the most commonly one used, is the neither of the above. So you have a brass alloy, for example, the most typical alloys that you are applying for, neither of the above will be the correct option. Something that doesn't fall under the previous two options, basically. So I choose the neither of the above, and then I move further below. It is a little bit more realistic. You can see it's a real substance, not a fake name. I have zinc with its EC number and CAS number. It's one of the composition constituents, because after I have linked here the reference substance for zinc, there is a new field, relevant chemical species type, which is relevant to metallic and inorganic materials, where I need to choose from a pick list options: composition constituent, composition impurity, and other. The first two will cover 99.9% of the cases. In my example, it's a constituent, zinc. So I select composition constituent. The empty setup value. I have made some calculations, and I will explain them in a moment, and I ended up with 2,250 micrograms per liter. And this is an empty setup value for zinc in metallic materials. Zinc in other materials may have a different empty setup value. So there is a basis for selecting the MTC value. I will go through the nested pick list. Sorry, I scrolled too much. I'll click on the blue. And here the basis is that I do have an SML value, a specific migration limit, which comes from the food contact materials legislation and which is no older than 15 years compared to the date when I submit my Drinking Water Directive application. This is in again in Annex 6 of Decision 365 of 2024, and it does say that you can use, actually you must use, I think it says, it implies that you must use an SML if it exists and it is not older than 15 years. Okay, so what do I choose here? I'm following the limit assessment approach. I have no tox data for zinc, but what the correct option is here in the second one, because my approach relies on a known toxicological safety threshold, the SML value. If I click on this little arrow to see what options are available, there are a number of things. It's not a parametric value I'm relying upon. I could use that if it was copper, for instance. There is a parametric value in Annex 1 of the Drinking Water Directive. Here for zinc, the correct one is the fourth sub-option. I use an existing SML value from Commission Regulation 10 of 2011, which is not older than 15 years. So this is the correct option to select. And then there is some justification, which previously, you remember, my justifications were a little bit repetitive. They didn't add too much extra value. But here you do need to provide justification. Why is it important? Because you start from an SML, and like when we have a parametric value, consider this example really relevant to those substances that have a parametric value, elements rather, in most cases. You do need to convert the parametric value or SML to an MTC value. So it's not the same as the SML. You need to adapt them. And to adapt them, you need to use the so-called allocation factor, also called ALF, and you need to explain what is your allocation factor. In the case of zinc, I'm explaining that I'm using an allocation factor of 90. These allocation factors are presented in Annex 5 of the second implementing act of Decision 367 of 2024, the European Positive List legal text. But it is not sufficient to simply take a percentage from there and just use it. You do need to explain the scientific justification why 90 or 50 or 10% is the correct approach, is the correct percentage. Now, you need to also be aware that this section 6.4 of Guidance Volume 2 is being now currently revised to make it a bit clearer. And in this new version that probably, I think I mentioned yesterday, will be released next month, we do make a distinction between allocation factor type 1 that you do not really need to worry about, and allocation factor type 2, which is the one we're discussing here, which could be 50%, 90%, 10%, which varies by element and varies by material type. Because as I mentioned before, for zinc, the allocation factor for organics could be something different, should be something different, rather than the 90% you see here for metallic compositions. So you do need to explain why you use 90, not simply say, I saw it in Annex 5 of the second implementing act. And this is what I have tried to put here quickly to say, this selection of 90% is consistent with ECHA's Guidance Volume 2, Section 6.4, where it is indicated that an allocation factor type 2 of 90% may be used where the toxicological value is substantially high, so that contributions from other sources into the drinking water would reliably not result in the exceedance of the toxicological value. This text primarily comes from the guidance. So if you make a reference to the guidance and justify why you meet the requirements of the guidance, this is all you need to do, but simply do not say I'm using 90% full stop. You need to explain why you use the 90%. Okay, so I have used the 90%. And I started with the SML value through calculations that it's easy to make, but I will not present right now. You ended up with expressed in micrograms per liter in 2,250 as the MTC tap value for zinc. The MTC tap and MTC tap remarks do not apply. Having said that, if you think about it, the MTC tap value for zinc is a bit of an MTC tap total, but to keep it simple, ignore these two fields. These are specifically for those substances which are relevant to organic materials, and they do come with an empty CTAB total value in table 3 of Annex 1 of Decision 365. So ignore this. Then the CTAB value. The CTAB value needs some attention here. Why? When you have a metallic composition and you do your migration testing, you are supposed to show that the CTAB value is lower than the empty CTAB value starting week 16. But you take several measurements. You will take in week 16, 21, 26, potentially even longer. Sometimes your testing could be up to 52 weeks. And you may also test in several test waters, test water 1, 2, or 3. So you end up with a range of CTAB values for different testing periods and different test waters. What you need to provide here in this CTAB field, which is obviously just a numerical field, is the highest CTAB value. Out of all the values you have, the laboratory has generated, you put here the highest. And accordingly, the risk characterization ratio needs to be the highest because you are dividing the highest CTAB to the empty CTAB, which is conveniently 2,225, and I end up with 0.1. Now, the other values are still valuable. So the other CTAB values and the corresponding risk characterization ratios are relevant. So what we are suggesting, and there is some explanation, I'm not sure if it's here. Yes, probably it is here. Yeah, this is the extensive help text in the CTAB field. I will not try to go through it, but the gist I will give you now. It basically says you may have for a metallic composition a wide range, a range of values. Please provide a matrix, a table, where you provide all the relevant chemical species, let's say the copper, the zinc, the aluminum, the lead in your composition, the relevant chemical species, with the different CTAB values and RCR values for the different test waters and the different test periods. And this table can be attached at the bottom of section 5.1, where you present your migration test results. So here is only the highest value. In 5.1, create a table, and you provide all the CTAB values and the RCR values for not only for the zinc, create just one table that have the zinc and the copper and the lead and whatever else you need to measure in the test water. So this is for CTAB and RCR. There is, of course, a second risk acceptance criterion. If you remember, this is in section 4 of the section 4.2 of Annex 6 to Decision 365 of 2024, where it says that two risk acceptance criteria for metallic compositions which are not passive is that the CTAB values are below the empty CTAB starting week 16, and also that the metallic concentrations do not show increasing trend. So basically they need to go down, to put it simply. You need to be aware of how to demonstrate this. And something actually, I think I missed something earlier. Yes, I will come back to that. I don't want to confuse you too much, but I want you to be aware in guidance volume 2, in section 6.5.2.1, 6521. There you can see the 3 different ways where you can show how you have met this second risk acceptance criteria, the downward trend. Okay, and there is a variety of ways of showing this, and some of them will be more or less feasible for you. In some cases, the values will really go down very clearly. So you have a little graph that comes from the laboratory. You provide this and everybody can see it very clearly that the values go down. So you don't need to do more than that. There will be other cases where the values go a little bit up and down. So in order to demonstrate that there is no increasing trend, you may need to plot the values into an Excel and create this to plot a linear trend in order to show that yes, indeed, my trend is going down. So it depends on what is the situation for your specific relevant chemical species. So there are 3 sub criteria how to show that you have met criterion B. That's how we call it. Criterion B is this not increasing trend. And here in this field, which is a free text field, you can just write which exactly sub-criterion you have actually met for this specific relevant chemical species. So what I'm highlighting now in this here in on the screen, this is one of those 3 sub-criteria which I have used in my exam to show that I have met this criterion. And the help text will help you as well. It's quite extensive. I will not go through it. Please take the time to look into this to explain. Finally, and I will jump back to the SML value because I did forget something important to explain. What we have also added in this version of Euclid, which was not previously available, is that when it comes to metallic compositions and risk acceptance documents in section 8 of Euclid, now we are requesting you to make a link to the relevant migration record where the results of the CETA values are explained for this relevant chemical species. I will remove this link to show you how it is done. There is this select button. I can click the select, and Euclid is clever enough to take me to section 5.1 where all the different migration documents are shown. Typically, there will be one only for the metallic compositions. There may be more than one. I have no idea if that will be the case, but I can choose from this tick box which one I want to make the link to. I tick the tick box, I select, and this is how the link has been done. Okay, and this is it. It's a little bit more complicated in the case of metallic compositions. Something I did forget to explain here is about the basis of the SML value, and I think it was there, but I don't see it anymore. Yes, the SML value. Yeah, somehow it was there, but it's not in this version. I will explain what I'm trying to find and I'm not finding right now. The SML value, as is mentioned in the legal text, needs to be maximum 15 years, adopted maximum 15 years prior to the submission of your application. So it is not good enough to simply say that my SML value for zinc is 5 milligrams per kilogram food. Okay, you need to demonstrate that it is indeed younger than 15 years old, to put it in simple words. And to do this, you need to make reference to the time that it has been adopted. Something that is missing from my text here. Maybe I made too many changes and I saved without keeping the important text in, is that there is a commission regulation for zinc, and I'm using this as an example, which is regulation 1416 of 2016. And this is the regulation which adopted the latest value of SML for zinc of 5 milligrams per kilogram food. So this was in 2016. If you make an application in 2027, it will be young enough, it will be valid enough for you to be able to use this SML value. But you do need to explain this in the justification here, which I somehow, although I had it here and I had made a note to mention it, it is not here anymore. So please it's very important, explain that the SML, when you use an SML, it is actually valid because it's not older than 15 years. If there is uncertainty to you as to whether the SML value you want to use is valid or not in terms of its age, our advice is to go to the European Commission to verify this. Go to Director General Environment, which is responsible for Drinking Water Directive, and check with them whether an SML value is valid. The SML values are adopted by the Commission, not by us, and we are not the authoritative source to tell you that for this substance it's good enough, for the other substance it's not good enough. And remember that this 15 years is obviously running. The more you wait, if you were to wait for 10 years to make your application, hoping that you are going to use an SML value which is now available, maybe by the time you need to use that SML value, it will become not valid because it's older than 15 years old. So please plan ahead. Do not get miss the train with this SML value because they do need to meet this requirement of their age. Okay. And apologies for not providing this. I can repeat just the name of the regulation because I was planning to put it on the screen anyway. Regulation 1416 of 2016 for zinc specifically. Let's move now to the final one I had planned, and maybe we have a little bit more time to take another one as well. We'll see. Maybe I'm taking too long. Let me see. What is the timeline for this, Hilary? What? I have 15 minutes. Okay. No, I have actually, I'm looking at the wrong side. I am supposed to have finished 3 minutes ago, so I'm a bit late. So I will finish with this very quick because it is very quick. It's about the passive compositions to see what happens when you choose the passive compositions. Material type is metallic materials. The type of metallic composition is okay. We saw earlier. I chose neither of the above. I had plenty of fields to go through. In this case, I choose passive metallic composition. And what happens, many fields just disappear, and there's only one new field that appears, which is the measured pitting potential. This is something that will come from the work you have done and presented in section 5.2. The one I will just try to open it just to remind you. This data on electrochemical test and passivation tendency of a metallic material. You take the conclusion from there, that one number. This is a field, a numerical field. You put the 750 and you finish. For metallic compositions which are passive, you need only one document in section 8. It's this one. It's very short, and you should finish in a couple of minutes. And I hope this was useful for the risk acceptance. Then I will try, we have finished with the demonstrations for today. We're gonna go to the presentation again, if I manage to make it activate. And let's see a few last points which are important before we go to the last Q&A session. Okay, the first thing is I'm going to look into two key functionalities of Euclid. One is the validation assistant, the other is the dissemination preview. Now, the validation assistant is an essential tool designed to support dossier preparation and submission. It performs several key functions, which is it verifies the data against regulatory requirements, what is in the legal text. It ensures that the data provided by the user are complete and they're harmonized. It supports applicants during the preparation of the dataset, so you can constantly verify to see what you have added, it makes sense. If it causes trouble, what is missing, you get messages to guide you as to what you need to add or to change. And then finally, it's used at the point of submission where it validates at ECHA, at the industry portal, whether your submission contains the required data. To be absolutely clear, the validation system does not check absolutely everything. And it's not the case that if you pass all the validation rules, you are going to be successful with the accordance check, or that RAC, the Committee for Risk Assessment, will give you at the end a positive scientific opinion. But at least it tells you that you are able to go through the submission process, and the most important, the most basic elements are present in your application. So the validation assistant works on the basis of a specific working context. In our case, is the DWD application working context that we discussed at the beginning of yesterday. To run the validation assistant, you need to press the purple validate button that you see in the top right corner. And you can do it while you are in your data set. You can do it while you are looking into your dossier when you are ready to export it and go and try to make the submission at ECHA. You can run it at any given opportunity. The most important thing that you need to be aware about after you have run the validation assistant is that there are two tabs in the validation system. One is the submission checks that you can see in that red box in the bottom left corner, and the other is the quality checks. The quality checks are something to give you alerts about something that if you wish to, you might ignore. But the submission checks you should never ignore, because if you fail the submission checks, then you will not be able to submit. You will fail them at the time of submission at the industry portal, and you will have to go back to the drawing board to open your dataset and make corrections, make sure you've passed the validation rules, and then try to create a new dossier, export it, upload it in the portal, and make your submission again. So do not ignore submission checks. If you want to pass the submission stage, you do need to have sorted out whatever the submission checks tab indicates. Now, the other thing that the validation assistant does is that it generates an Excel file with a summary of what the results of the validation check has been. And this can also be a useful resource. You can go, especially if you have many perhaps mistakes or omissions, you can go through them systematically to identify what is going wrong and go back to your dataset to make the necessary modifications. We have been working extensively on validation rules. There are several validation rules that are running right now in the Euclid version that was released at the end of April, but we are further working on new rules and the maintenance of the existing rules. And we have now a focus on Section 3 to help applicants provide the necessary information on physicochemical properties, and Section 7 to make sure that under the different scenarios, the correct toxicological data are presented by the applicant. We will also look into the substance identification checks that will run on the relevant chemical species which are linked in section 1.5 of the main dataset. We do have this complexity compared to other working contexts where we need to combine multiple datasets into one single dossier. So validation assistant, the key message here is please use it. Use it a lot. Use it as you move forward. It will really guide you as to something is missing or things you may think that you have done them well, but if you run the validation assistant, you may get a message to indicate that maybe something is not right. The second tool that I would like to highlight from Euclid that you need to be very familiar with is the dissemination preview. This is a plugin that allows users to simulate what is going to be published by ECHA and what is not going to be published by ECHA. And the publication of the applications, the same thing that is happening with notification of intention, happens on the ECHA database. There is a link to it. You can follow it once we upload the slides, but of course you can search for it on Google and you can find the ECHA database. Now, the simulation that is being run by this plugin is based on the requirements of the legal text and specifically Article 10 of Regulation 369 of 2024. There it explains what information is confidential. Okay, and generally the hierarchy, the hierarchical approach to this is that everything is published with the exception of certain things that are set out in this Article 10 of Regulation 369. So to do what you need to do in practice to run the dissemination preview, your first step is to go to the top right corner as you see your dossier, not the dataset, the dossier. You click the three dots button, then you scroll down to the dissemination preview, you click that, that's your second step, and the third is to select the view report and create filter dossier, and that will create, first it will generate a new version of the dossier that does not contain the information not to be published, and second, there will be an Excel file where you can see in full detail. Actually, you can see it now on the screen. You have the filter dossier that is being generated. You can see the name of it. It's in the first, the top red box where it's now called filter DWD notice. This is for notification, but still you get the idea. And the second is that you get an Excel file. The Excel file has all the fields in Euclid, where the outcome in this column A of the Excel screenshot, you can see whether something is published or not published. And if you find that something is published that you do not want to have it published, you need to go and remove it from that place. Okay. The one important message about confidentiality from today's meeting, and I think we're going to go into this in more detail at the next workshop we have in October, is that the applicant is responsible for the information they include in their application. This means that confidential information must only be placed at the places where they are marked for confidential information in the correct fields. And the Euclid application manual does explain this in more detail that I can offer you right now. Now, if you don't want something to be published, you need to exclude it from your dossier. Something else that the Euclid manual explains and you need to be aware of Contrary to what happens in other regulatory processes, for each, for example, there is a possibility of making claims that I would like to claim this is confidential. You may need to provide some justification why this is confidential or not. We do not have this process for the Drinking Water Directive at all. Certain fields in Euclid are confidential, the rest are not confidential. This is how it works. And there is a question that came in on Slido about attachments. I will come back to that when I will respond to those questions, so I will not repeat myself both now and then. Something else that you need to be aware when it comes to data protection is that you must have permission to use and publish the information you are providing to us. To give you an example, and something we have actually experienced by discussing and engaging with a number of potential applicants, you hire a laboratory to do a migration test for you, and they provide to you a report at the end. So this test report may have the name of laboratory technicians, their names, signatures, email addresses. You must have approval from them to use this information, their personal data, and actually to have this published by ECHA. Okay, if you do not have that approval, either you ask them to remove it from the report they gave you, or you redact it in this report before you submit it to us. Okay, we will not be doing any cleanup operation for you. To be absolutely clear, you have a letter from an authority that you want to share with us, show that my substance, my composition has been approved by ministry or agency of whatever in whichever country, in whichever member state. There you may have the name of the authority official, a signature, email addresses. Before you use this to attach it in your dossier, please redact. Of course, first, please ask for approval from them if they allow you to use this information, and if so, please redact, remove the information which is personal. We would not like to publish personal information just because you fail to take care of this at the time of submission. Something else to be clear, and I think it was mentioned already earlier, migration test reports and analytical assessment reports will be published. This very vital, important information will be published. You cannot claim confidential migration test report you have received from a laboratory you have received. So please take the time to understand these rules and do your submissions correctly to make sure that there's no trouble further down the line, including between you and service providers you are using for the purposes of the applications. Let's take a look at the timelines. The notification of invitation, as you know, has started. We started on the 5th of January this year, and notifications are being made through the new industry portal. Applications will also be made through the industry portal. And also at the end of March this year, we also initiated the notification process for authorities. And authorities are using, member state authorities, I mean, they're using their own portal, the authority portal. There's no link there because you need to be registering with us first before they have access to that specific portal. Just to be transparent, we have not received any submission of notification by any member state authority, but even if we had received, we would publish them alongside the different notifications we have received from economic operators. Now, the application started at the beginning of 2027, early in January. The legal text does say the 31st of December 2026. We will not open the doors in the middle of the New Year holiday, so it will be very early in January. The exact date will be announced later this year, will be something similar to what we did with a notification, which was 5th of January. It will be around that time as well next year. So from January 2027, you need to consider if your substance or composition or constituent is not on the European positive list and you want to add it to the European positive list, then first you need to submit a notification of intention, and within 12 months to submit your application to have this substance added to the list. After you submit your application, the ECHA will assess whether the application is in accordance with the legal requirements. Then we're going to hand over your application to the Committee for Risk Assessment, in short, RAC. Hopefully, the committee will issue a positive scientific opinion on your application, and this application will be the opinion, to be more precise, the opinion together with the application will be sent over to the Commission, and it is the Commission that will decide whether your substance will be added to the list or removed or stay on the list, whatever the request from your side is. You also need to be aware of an extra step that happens outside DECA and we don't have control over it. Within 2 months from the Risk Assessment Committee issuing a scientific opinion on your application, you must provide samples of your substance or composition to the Commission, specifically to JRC, the Joint Research Center, which is part of the Commission. There is, I mentioned at the beginning of yesterday, and I think I will mention in a coming up slide very shortly, there is a guidance document of what sort of sample you need to submit to them, because there are requirements on the amount, the volume, the dimensions of the sample when you send it to JRC. So do not really ignore this necessary step, which of course happens outside DECA and we're not really involved. We are only hosting a link to the guidance on our website. So what happens after the European Commission decides on the application? Then there will be a change in the official journal where the decision of the Commission is published. If something is to change in the positive list, to add a new entry, to review it, to give effectively a new expiry date into the future, then this will change. And only then a new substance that is not currently on the list can start being placed on the market to be used to make materials in contact with drinking water. What is the bottom line of all this? This is a process which will take some time. It is not something that you can submit in January and you expect by February to have a decision by the Commission to tell you, yes, please start using the substance. It will take more time. Now, I would imagine that you may wish to apply early enough to be able to get the substance to be available for use as quickly as you can. But then it's really up to you. You need to plan ahead to see what is your requirements, how you can collaborate with others, and so forth. Now, if your substance is already on the list, you need to consider the expiry date. If you have obviously an expiry date of 2037, perhaps you don't need to do much right now. However, you also need to consider the approval conditions. Maybe you use the substance in ways that are not really specified in the positive list, and you may have good reasons to come early to make the application, to change the approval conditions, to make sure that you can start using the substance the way, or you can continue if you already using the substance to make sure that your use is being actually covered properly. Now, moving on for the, we're supposed to go into coffee break, but I will take a little bit of time. Actually, some important elements are coming up. You need to know that if your expiry date is the 31st of December 2028, you need to consider the provisions of Article 3, Paragraph 9 of Regulation 369, because what do these provisions say? If you submit a review application by the end of June 2027, then the expiry date of the end of 2028 is suspended, which means the Commission may take a lot of time for whatever reason to give you a decision on this substance, on this application. However, this substance can continue being used beyond the expiry date because specifically you managed to submit the application early enough, which is by the end of June 2027. A couple of small points to add here as well. A notification of intention is valid for 12 months. When you submit your application, you must have a valid notification of intention in your hands. And of course, we would, as you would expect, we would ask you to notify early because it gives us more time for us to know what is coming up, to plan ahead, and gives more time to you as well to plan ahead, to collaborate with others, find the information you need, signal your intention of covering the substance, supporting the substance. Other people can come together to support you, to provide data to you. So it has significant benefits, but we do understand that some people may wish to be late. It's not going to be helpful to us. Let's put it like this: coming very late with a notification is not going to be working well. And one last point is this collaboration I have mentioned, it happens completely outside the process. It is not really something that we are managing, something we are supporting with. It's really up to you to find out relevant people to discuss and make the necessary preparations. Important points here. The application is much more complex than the notification. There are a number of questions that I will not go through in detail, but please do take the time to consider them. You need to understand what you are applying for, why you are applying for it, what are the uses, what are the relevant chemical species. And sometimes to understanding all this, it's not something that happens from the very beginning. You need to understand the process, how the notification, the application link together. You need to understand what data you require, what drives these requirements. Example, we have explained several times already. Migration tier defines how much stocks data you need. And then you need to consider, do I have the data? If I don't have the data, do I have a plan to get the data? Who has the data? How can I update them? Costs and all these things that obviously are outside our area outside our mandate. It's something that you need to consider yourself. And then, of course, you may need support. You may need to go to a laboratory. There may be many people who need to go to a laboratory to get a test done. So please consider this. Do not leave things for the very last minute. It's better to plan early and be early. And one point to make very clearly, once you start the process, there is limited time to correct things. You need to do a very good job from the beginning. Aim to have a complete dossier from the beginning rather than come with a half-done dossier and hope that in the process you are going to improve things. Because if you don't do a good job from the beginning, you're going to fail probably the accordance check. You're going to be given some time to correct it, but the time will not be sufficient potentially to generate new data, to find new data, to address the issues that we have identified. This I will not have to go through them in much detail because you will find the slides uploaded on the event page afterwards. But very briefly to give you an idea, a snapshot, a very quick snapshot of what is available out there for you. If you want to you are starting from zero, go to our Drinking Water Directive page. If you want to see the European positive list, of course, the authoritative source is the official journal, but we also have it published in the ECHA database, and there you can download as an Excel file as well, where you can filter, you can search it, perhaps you can manipulate it more easily than a 350-page PDF document. If you have any questions, if something is blocking your progress with Euclid or even deciding whether to apply or not, please contact our help desk. There is a specific contact form for Drinking Water Directive queries, and the sooner we hear from you, the better. You can come back with follow-up questions, and as I mentioned before, you can contact us many times now. Once the process starts, the exchange we have between us and the applicant is dictated by the legal text. We cannot constantly be on the phone and discussing with you what has happened with your application. So now we can help you much more. Once you enter the process, we need to follow a specific process. There are many things we have made available on our website. We have a summary of the relevant legislation. We have issued a decision on the test methods you can use for physicochemical properties, toxicological properties, migration assessment. There is a current list of metallic composition categories, which comes from the guidance, but we have a separate document linked through what you see on the screen, and we will continue to updating this much more often as we receive applications and we have approval of new alloys in the positive list that create new metallic composition categories. We may also modify existing composition categories as a result of applications. We have issued, as I mentioned, 4 volumes of guidance documents, big documents, plus the one from JRC on providing samples to them. There is a very important resource, this infographic, which we call sometimes the metro line, with the different steps from the very beginning when you start realizing what is Drinking Water Directive, do I care, do I want to do something, who needs to do something about it, all the way to preparing a notification of intention, submitting the notification, preparing the application, submitting the application. These steps, which are very important until the submission, are now ready. You can go and read it, and this infographic will lead you to the practical guide, the next link on the slide, where you can get really practical advice how to start getting things done. And as we move forward for the rest of 2027, we will build up the infographic with other parts that are relevant. For example, the accordance check, what happens with the consultation of third parties, the opinion making and track, and so forth. We are expanding our Q&A database. We have the IT Tools user group, which we are running with people from different stakeholders who are helping us with Euclid development. They give us feedback on something working or not working. We are welcoming new members. There's an email address to contact if you wish to join us. We publish also the slides from those meetings for everybody to see. There is the generic Euclid support link you can follow, the industry portal through which you make your submissions. You can go even now, and there are some helpful resources, including videos, to see how easy it is to actually use the industry portal to make your submissions. And if you want to know more about specifically notification of intention, but also how to create the NECA account and so forth, you can go to the workshop page from 2025 in October, where we have lots of materials there as well. And I will finish. This is my last slide, and I'm now 7 minutes over time. We have a new event happening in October. This, if we have sufficient interest, we're going to have it as a hybrid event. So some people will be present here in Helsinki, others may follow online. This will be 21st and 22nd. We will have presentations from the Commission. We will be discussing with notified bodies to have input from them. Potentially other actors and stakeholders will be invited to explain, to share with everyone their experiences from the process, with the process so far. Another small point, but important perhaps for some of you, is about biocides. There's a new Q&A on our website that has been published, and I really strongly encourage those who deal with biocides to visit it. Biocidal active products, as far as active substances to be accurate, we believe they're relevant right now for cementitious materials, but you need to be aware that they must be approved under the biocidal products regulation to be eligible for listing in the European positive list. Currently, the reality is that there are 7 cementitious constituents which are not approved under the BPR, and they are still in the European positive list. This will be removed by the Commission from the European positive list. Please be aware, go to the Q&A. If you are dealing with biocidal active substances, you may be affected. And finally, to give you an update on notification of intention, as of a couple of days ago, we expect 36 applications to be submitted to us in 27 and 28. I think there was also a question in Slido about this. And the majority of these notifications are planned to be are linked to intended applications for new entries in the European positive list. And that's it. We're going to take a break. 10 minutes. Yeah, let's make it 10 minutes to have more time for the Q&A. Have a drink, like I will try to have as well. And we will be back in 20 past 4 our time, 20 past 3 CET. I hope it has been useful so far. So I will change this slide as well to show the correct time. Thank you. Hello, welcome back. I hope you. I am. Yeah, I need to do something. Thank you, Hilary. If I manage to get my mouse there. Yes. Okay. Soon you will be able to see the questions we have been receiving and we will be taking now. Let me take a look to just organize myself because there's quite a list. Okay, I will start with the first one. We can highlight as well. Thank you. That came from Javier on valves, taps, pumps. There are a lot of organic components, gaskets, O-rings made of natural rubber, FKM, EPDM, etc. Not one of these materials is approved on the actual EUPL. No matter these components are approved by Kiva, ACS, WRAS in the UK. What we have to do next year for new products, we cannot use them. Any idea? Okay. First, the European positive list does not list products, does not say anything about gaskets or rings. It may make some mention in certain cases in the conditions of use, but the positive list is a positive list for starting substances, compositions, and constituents. So you need to be concerned as to whether the starting substance for making NBR, FKM, EPDM, or whatever else is on the positive list. A bit earlier, I was trying out of curiosity to find out whether something's the positive list. I also wanted to highlight something which comes from Article 3, Paragraph 4 of Regulation 369 that says, in the case of a polymer intended as a starting substance or as organic cementitious constituent in the manufacture of cementitious materials other than admixtures, the application shall be made for the monomer in the case of a polymer not used as an additive. I assume here, I make the assumption, just as an example, but to guide you a little bit to this, Article 3, Paragraph 4 of Regulation 369, which basically guides you as to whether you need to have, what do you need to have on the positive list, the polymer or the monomer. And I have taken a very brief look at the different monomers for what is mentioned in the question, just out of curiosity, if nothing else. For NBR, natural rubber is listed anyway under EUPL 0499. Acrylonitrile is EUPL 0169. Butadiene is 0168. The same thing for EPDM. I have a long list of potential monomers which I have here. There's the ethylene, propylene's listing, DCPD, several for the FKM, vinylidene fluoride is under 0079. Hexafluoropropylene is 02224. So you should not expect in the positive list to find O-rings or gaskets, but you need to find out whether the monomers for polymers, which are the main structural component of these materials, is actually listed. And indeed, these monomers I have read now, with the exception of a couple, they are actually listed there because they come from the food contact materials positive list, the plastics, and all of them are right now approved for all material categories. So for plastics, for rubber, for whatever. So do not expect to find these components that you mentioned in your question in the positive list. Look for the monomers in the case of the polymers which are not used as additives. And if you have more questions, you can come back and ask us at the help desk. Let's move to the next one. Yes, that's a good, a very timely question by Axel. Is there an overview in Euclid of, not in Euclid, but there is an overview of all substances for which a notification of intention has already been submitted? This would ensure that we would not inadvertently notify the same substance hundreds of times. Yeah, hopefully not hundreds, but if it's 2 or 3, it won't be hopefully the end of the world. Yes, what is happening now? You need to go to the ECHA website. I think we can, I don't know if I can do it now by sharing my screen. It will be a little bit complicated now. But in the ECHA website, as of a few days ago, there is a possibility of downloading as an Excel file, a very simple Excel file, which shows you all the substances and compositions for which notifications have been submitted. So we will try to put something in our in the materials we upload at the event page, but there is now a possibility of downloading them all as a simple Excel file. The Excel file gives you basic identification of the substance and compositions and a link to the substance overview on the ECHA database where you can find more details. So that Excel file will not tell you that this substance has been notified for plastics and it will be the application will be submitted on the 1st of February 2027. This detail does not exist, but it can guide you to the correct substances, their overviews to see what is the situation for notifications. And if I have the chance at the very end of the process where I need to start moving to different browser windows, I can try to show it live, but now it's better to stick to the list of questions rather than confuse our IT systems. Thank you for the question. The next one is, are there any plans to incorporate member state level positive list substances granted after 2021, after 2027? This is a question that needs to be addressed to the Commission. The Commission has not taken any action for this. We, from our side, we cannot do anything. The current situation is that you need to make an application to proactively add these entries in the European positive list. There is transitional provision in, I think it's Article 3 of Decision 367 for this nationally approved entries between July 21 and the end of 26. But to the point of your question, no, there is no automatic transfer from positive list in the member states to the European positive list if this has happened in the member state after July 2021. The next one, between application submission and EUPL expiry, if medium or major revisions are identified despite good faith submission, will applicants be given time to provide further information after the expiry date, and will the entry remain temporarily valid during this process? The entry remains temporarily valid for an entry that already exists and you're submitting a review application. That's my understanding here. It's only defined by the legal text Regulation 369, which is, as I explained earlier, taking the end of 28 as an example. You need to submit your application by the end of June 2027, at least 18 months before the expiry date, for this expiry date to be suspended. There is no other legal provision where we can suspend this expiry date. Now, I'm not sure exactly what you have as in mind about medium or major revisions. The important point here is that once you have made your submission of the application, spontaneous updates are not allowed. You can only make updates upon request by ECHA. So after a failed accordance check, we will come back to you with a communication. As I explained yesterday morning, we're going to tell you that, section 6 is missing this, section 7 has XYZ problem. So then you will have the chance, according to the legal text, to take the time to submit additional or better information. After that, once the Committee for Risk Assessment, RAC, will start doing the work to develop a scientific opinion, they do have the possibility, not the obligation, but the possibility to come back and ask questions, to say, we would like you to clarify something in your application which is not clear, including to make a request, if they consider it necessary, for a full study report as opposed to the robust study summaries that Vessel and Hilary were presenting earlier. So there will be a possibility to provide something, but in response to the questions you have received. And generally, these questions will be for clarification. It will not be, please go away, produce new data and come back. The clock doesn't stop. If RAC makes a request for information, it's not that we send you the questions, you go away for a year, you do your studies, your tests, and you come back and say, oh, I have new data. These questions will be for clarification. You will be given a reasonable amount of time. Let's say it's one question, you may have 1-2 weeks to respond. If it's 3 questions or 4, maybe a little bit more, just to give you a feeling. Don't quote me on the numbers, but there will be something short. It will not be, please take your application, improve it in a major or medium way, and come back to for us to continue our opinion making. I will take the next one as well about the setup of metallics. I take it from, I will read it out as well. To derive a setup for metallics, there was a 26-week duration time. This is the migration test duration. Hypothetically, starting now, the results would arrive in mid-December, and only then the number of toxicological studies can start. The first deadline for submitting the DWD application is June the 30th, 2027. It is a deadline, it is not. I mean, you can submit later on, but clearly there are benefits of doing that. So let's take it as it is meant here. How does ECHA view all this? Okay, the first comment is that an element, I assume from the question is that it's not a composition that has only copper, zinc, and lead and nickel, for which you don't need any tox data, but it is something that contains perhaps more exotic element that you need to provide tox data because it doesn't have an empty setup value or parametric value and so forth. The first key point is that whether an element, a metallic element, is a relevant chemical species or not is defined in the legal text. Again, you need to go to section 1.5 of Annex 4 of Decision 365 to find out that, as an example I used, I think yesterday, if silicon is an impurity, it is not a relevant chemical species, and you finish. You don't need to do any testing for silicon. I don't know if silicon is a good example, but just to give you an example. So from the very beginning, you will know, and I will take bismuth. I think I mentioned it yesterday. Maybe there was a question. Apologies to people who really deal with bismuth. But if you are looking into, I have an alloy that contains bismuth, you know from the beginning that it's going to be a relevant chemical species. The minimum you need is genotoxicity data. You don't need to wait for the 26 weeks for the migration testing to happen to collect genotoxicity data. You will always need them. This is the minimum for toxicological information. So start with the genotoxicity data, okay? Then when they do this testing, obviously over 26 weeks, sometimes, as I mentioned, could go up to 52 weeks. At week 16, you're going to get some information. I hope you will be able to keep in touch with the laboratory to tell you what the results have been. At week 16, they will give you some information, which could be useful. Hopefully, I cannot guarantee this will be the case, but in most cases, in many cases, the concentration should go down. So what you get in 16 weeks should be a fairly high concentration setup value, and then it should start going down in the remaining duration of the test. That setup from the 16 weeks potentially will give you an idea whether you are heading towards a setup value which is in the medium or the high migration tier. The other thing that you need to be aware, especially for metallic compositions, is that the setup value is, as Nico explained, you take the MEPs, these equivalent pipe concentrations, you multiply by A, which is the factor that indicates what is the percentage of surface in contact with drinking water. It could be 100%, could be 10%, 1%, or something very, very small. You can see, obviously, from the MEP values, this equivalent pipe concentration values, which way you are heading with your setup value. And maybe there you need to make a decision whether you want to apply for category B to D or C to D or something to see what the situation is in terms of how high the setup value is, how much toxicological information I may need. But at least in 16 weeks, you will have an indication where you're heading to. The most important point is from the beginning, you know if it's a relevant chemical species, you always need toxicological information in the form of genotoxicity data. Start with those. Don't wait for weeks and weeks to find out whether there is genotox data out there for this element. The next one, is there an age limit for the provided data? Yes and no. Generally, no. I don't think there is any age limit. You just need to meet the information requirements. Something that else that happens, and my colleagues, the toxicologists, can provide more concrete explanation than me. You do need to meet the relevant, obviously, the standards or the technical guidance documents from OECD and whatever. So if you have a very old test that has been done from, I don't know, genotoxicity 20 years ago, I don't know if that's a good example, vessel 20 years ago, maybe it doesn't follow the latest standards. So you need to show in your application how how those old data can meet the requirements of the technical guidance right now. So an age doesn't exist, but you need to meet the requirements. Do your old data meet the requirements? This is the key question you need to be able to address. If nothing has changed, I don't know if it's a relevant example, but if nothing has changed in the technical guidance, or in the EN standard that under which you did the migration testing 10 years ago, as long as the substance has not changed, the composition of your alloy or whatever has not changed, I don't see why you should have to prepare new data. But it's really a responsibility on you to make sure that what is required in the legal text and what is explained in the guidance can be met by what you have in your hands. Maybe your question is very short, and I hope I'm responding correctly. If it's something you can further clarify, please let us know. Send a follow-up message. Then the next one we're going to move to by Adam Frosch. How is the fraction of post-industrial recycled material, PIR in-house, in the material handled? For example, there is some reflection on the screen. A 10% PIR content in the polymer. The test reports were conducted only for a 10% PIR content and for materials without any PIR content. Does this 10% cover all PIR contents ranging from 0 to 10%? Would you like to take it?
Sure. Yes. So just to answer, how is this handled? Well, unless you are applying for this to be on the positive list, it's not really handled. So what you do is you apply for something on the positive list, and then you describe your material. And here is the material is not really mentioned here, but post industrial recycled waste. So when you do your migration and you use a material that contains something like this is of course something you should disclose in the migration test piece formulation. And also, if you know the contents ranging from 0 to 10, you should think about which one would affect the migration the most. But you could indicate the 10%, or in this case, the average would be 5. But unless you're applying for this material, all you should do is just disclose this in the migration test piece formulation. And also, when you are declaring the intended use, you need to disclose the correct kind of material. So if our PIC lists at the moment do not cover material containing this kind of ingredients, then you should explain somehow that you have this there as well. I hope I'm answering the question here.
Thank you, Nico. Yeah, if we have not answered, please come back. Now, the next one, I will read it out. Give me a second. So if a prepolymer is in the positive list and used in coating paints, the paint is in compliance and the migration test shall be on the prepolymer. Is this correct? Just to be sure understanding is correct. Nico.
Yes, so in fact, as said, the European positive lists only is for containing substances which are accepted to be used in the drinking water contact materials. So just because you have a prepolymer on the European positive list doesn't necessarily mean that the coating or the paint you are using it in is in compliance. But this is correct that the migration test shall be on the prepolymer in this case. We have actually, this is somewhere stated in the legislation, but also we have this ECHA guidance volume 3 about the scope, where there is a table explaining about polymers and prepolymers and monomers, depending on what type of use you have for it, what the application shall be for. And it says there that when you are using a prepolymer in a coating system, then the application for the EUPL is for the prepolymer.
Thank you. Again, to repeat, the certification of products is outside what we do. Whether the product will be certified is a different process that happens by notified bodies. Let's go to the next one by Nicolas Delfaux. Some epoxy reactive diluents have recently been self-classified as CMR1B after an intensive daily oral gavage of rats during 10 weeks, irrelevant to the user's heavy-duty epoxy tank linings. Such products benefit from attestations of sanitary conformity. What about their forthcoming conformity? Vesela, would you like to take it with my initial reaction that if it's about conformity of products, again, we are not the right people to provide advice because it's outside the mandate of ECHA. We are dealing with the maintenance of the positive list.
Yes,
Vesela, please.
thank you, Panos. Indeed, we are not dealing with conformity, but I can focus on the first part of the question that it's more on the toxicological part. So first of all, from a scientific perspective, hazard is an intrinsic property of a substance. And in such case, it doesn't depend on particular use. So basically what here the person that asked the question states doesn't really make sense, and it's not really correct. Even though it is not specified in the question what is the exact hazard of the substance, it could be C, carcinogen, or mutagen, or reproductive 1B. It's also not specified what is the type of this study, what is the design of the study. It's a 10-week study, which is not a very long study. For carcinogenicity, the study is 2 years. So even though this information is not provided, the mere fact that the observed effects after this, as I said, relatively short exposure period, meet the classification criteria for CMR category 1, this would indicate that the substance is highly hazardous. And according to the drinking water provisions, this substance can make it to the European positive list only if meets the provisions that are set out in Section 1 of Annex 6 to the implementing decision 365. And to be more correct, I have this in front of me, so I would just read it out loud in order to be correct. So per section 11A, the relevant chemical species is non-intentionally added substance, substance constituent, or starting substance on organic cementitious constituent that is a monomer of a main polymer of the contact material. So if this is one of the case of this substance that is asked for, so it's a relevant chemical species, and it can make it to the positive list if it meets the criteria. First, the CTAP is lower than the generic limit of 0.1 microgram per liter, or the relevant empty CTAP derived from a parametric value, which I think it's not the case here. It's below under the limit of 0.1, and the concentration of the starting substance, organic cementitious constituent or NIAS, in the final material is below 0.1% weight per weight, or below 0.02% weight per weight where physical migration testing is uncertain. So if the substance referred in the question meets or doesn't meet any of those criteria, it cannot be used in manufacturing of materials that come in contact with the drinking water. So in this situation, indeed, it may affect the conformity of the product. So I think a bit long answer, but also the question was, it was an interesting question, content related question. So thank you for it.
Thank you, Vesela.
I think because, sorry, Panos, to take the floor again, the next question that it comes, which is for an SVHC substances, I think it's somehow related. Shall I?
Yes, please, of course.
So I can read it first. If a substance is an SVHC or under SVHC assessment, how should Yeah, thank you. How should very low migration into drinking water be addressed in the DVD risk assessment and weighted against related REACH I assume, tox concerns? So basically for SVHC substances, they should follow the short risk acceptance methodology, the limited risk acceptance methodology, meaning that the MTC tap for them is 0.1 microgram per liter. So this is what should be considered in their risk acceptance. There's no need here, and there's not in the provision of the Drinking Water Directive to compare the toxicological properties compared to REACH. If the substance has been identified as a very high concern, that's sufficient, and according to the DVD provisions, it should have a 0.1 microgram per liter as an MTC tap. I hope that that clarifies.
We can continue with the next one, Vesela.
Yes, indeed. Do the waiving argument for CMR substances only apply if a harmonized classification exists for the substance, or do the waivers also apply if a plausible self-classification has been provided? So basically it applies for both. Yes, it says classification, and the classification includes both harmonized and self-classification. This is the short and clear answer to this question. Thank you.
The next one is again for you, Vesela. Please go ahead.
Yeah, I think also next one I can take. I'll read it first. It is difficult to predict if there will be a cocktail mixture. How can we determine the different substances and the human risks? Which tests should be performed? So if the cocktail mixture here, I'm not quite sure what it refers to. It could be referred to the mixture in the material, but we are not interested here on this. It could be also referred to a mixture in the drinking water. So first, as Nico has explained during his presentation on migration, the applicant should know what is the substance, the applied for entry that they are applying for. They need to know the composition of the substance, so its substance identity. They need, based on this, they need to have information on what it's provisionally to migrate and what to look for in the migrating water, and then to identify what it really migrates. And to identify the migration level of those relevant chemical species that could be impurities or breakdown products, or something which is formed in contact with water and it's not part of the initial substance. If something has not been identified, I understood that there could be this screening test performed that would identify or give an idea of substances that could migrate. For tox data, as I explained, it's for the relevant chemical species based on the migration. If some of the relevant chemical species are the one that cannot be isolated from the drinking water because they don't exist as such, information using general rules for adaptation could be used. If you have several, I mean, I'm just kind of now speculating. I'm not an analytic myself, so I have no idea how it works, but I'm sure that people that work in these laboratories, they should know. to identify what substances or what are the components of, let's say that there is kind of a mixture identified. If these components exist as substances, they should be tested. If they do not exist and they cannot be isolated and synthesized for the purpose of the testing, then adaptations would be used. And for example, read across could be used. So whatever is tested as a representative substance for the mixture should be justified that it covers the properties of the other substances in the mixture. It's a bit complex. It's not very easy. And under the other regulations like REACH, for example, mixtures are not really looked at. So substances as mixtures are not evaluated. But this is what I can answer to this question. I hope I also grasped correctly the question. Thank you.
Thank you, Vesela. We'll move to the next one. Yes. Is it necessary to attach the study reports under attached documents sanitized for publication? That's a sanitized version has to be created, deleting confidential information, or can it also be attached under attached confidential information? You need to look into the Euclid application manual. I'm trying to find the exact section 5.3, which is explained that the attached confidential document column of those tables should not be used. Nothing to be attached in the confidential column. Everything goes into the sanitized documents. And actually, our intention is to have to develop and implement a validation rule. So if somebody tries to attach something in the confidential attachments area, the validation rule to fail to give you the message that you can't really be attaching it there. As I mentioned before, attachments will be published. So not two versions of attachments, use the sanitized area in the confidential information column. Please do not attach anything. You will fail the validation rule that is coming up. Let's move to the next one, which is for Hilary, perhaps.
Yeah, thank you. So how can we reduce the amount of test animals needed for Drinking Water Directive toxicological data validation? And indeed, animal testing should be considered a measure of last resort under the Drinking Water Directive. And there are several approaches. First of all existing information must be collected and assessed before new tests are carried out. And then there's possibility of applying alternative non-animal methods, such as, well, I mean, of course, in the low migration tier, only in vitro methods can be enough, and can of course can be used also in other migration tiers where applicable. Then in silico and modeling approaches such as QSARs can be also applied where possible. And then there's read across grouping and applying a weight of evidence approach, of course. And most importantly, when testing is unavoidable, it's important to avoid duplication through collaboration, and notification of intention process supports this. So also you to identify the other applicants and collaborate and reduce the duplicate testing. And of course, when testing has to be carried out, the testing should be optimized. So, for example, combining reproductive toxic screening and repeated dose toxic studies, or including satellite groups for toxicokinetics, for example. Thank you.
Thank you, Hilary. The next one, perhaps for you as well.
Yeah, I can take that one. So what is the appropriate test material when toxicological data is required for metal as radiochemical species in a particular application? The metal itself or metal salt, and which metal salt should be selected? So for metals, the toxicological assessment under the Drinking Water Directive should focus on the relevant chemical species in drinking water, meaning the actual dissolved form of the metal. And as a general principle, the bulk metal itself is not the appropriate test material for hazard assessment. Instead, it should be based on bioavailable form that represents the, as I said, dissolved metal species. In practice, this typically is achieved by using soluble metal salts, and it's important to avoid introducing additional toxicity from the counter ion. Yeah, no specific salt is prescribed, but however, simple, highly soluble inorganic salts such as chlorides or nitrates are generally considered appropriate when scientifically justified. Thank you.
Thank you, Larry. I think we're gonna stick with you as well. At least that's the indication I get on my screen. The 90-day study.
So is it necessary to report the key study, for example, 90-day study that serves as the basis for DNO and the MTC TAP in Euclid, even if the only data requirements for the relevant chemical species related to genotoxicity? If so, is it possible to report these studies in a non-robust manner using secondary sources? So if we think about low migration tier where only limited information, meaning, for example, genotoxicity is required, additional systemic toxicity data may not be necessary for compliance. However, if the DNO or MTC TAP is derived from a specific study, the dossier must still justify and transparently explain the basis for that value. And importantly, where a study is used as a basis for DNL or MTC TAP, the information provided must still be sufficient to allow independent assessment. So reporting only high-level information from secondary sources would generally not be adequate for this purpose. Thank you.
Thank you, Larry. I think we're gonna stick with you. I don't know. It's something for you or Vesela. For you? Okay. Vesela then.
Yes, so I can read it. When it comes to genetic mutation testing in mammalian cells, does it matter whether a mouse lymphoma assay or an HPRT assay is used or reported? So for a regulatory purpose, both assays are accepted. So the two guidelines, OECD test guideline 490, which is the mouse lymphoma assay, and the OECD TG 476, which is a HPRT assay. Both are acceptable. Of course, the toxicologists would know that there are some differences in the sensitivity and the specificity of those assays, but this wouldn't affect the type of the assay, as long as the study that it's provided is reported, well reported, and the data are relevant, reliable. It would be accepted.
Thank you, Vesela.
I think that also the next question I can take, it's a very short answer as well. Could a study proposal be included in the dossier in case where a data gap has been identified and there is insufficient time to complete laboratory migration testing? Unfortunately not. The Drinking Water Directive does not foresee testing proposals to be submitted. So you have to, when you send your application, you have to have all data available already. As Panos explained, once the process started, we cannot stop the clock waiting for some data to be finished, to be finalized. So the main message, I think, from all these 2 days should be that, and I hope that you understood already, that you have to come prepared. You have to, when you start sending your application, you should have all the relevant and needed information to cover for all information requirements, starting from migration and going to toxicological studies. And also the next question, is it necessary to attach the GLP certificate as proof of as proof of GLP compliance. It is not a must, but if you have the certificate, it's good to be provided. Of course, it could always be requested by ECHA if the evaluator from RAC considers that he would like to see and have a proof that indeed the laboratory where the test has been performed is GLP certified. So it would be a good practice to attach it, but as I said, it's not a must. But if you have it, yes, I would advise you to do so.
You can take the next one, Vessel, as well.
Yeah, I'm reading it. I can take it indeed. If the results tables of the genotox studies are missing, is the applicant requested to submit an update, or is an MTC tap of 0.1 microgram per liter automatically set on the basis of information not sufficient for assessment? So the evaluation of the results would be done by RAC. So it would depend on the evaluator if he or she would like to see the full the tabulated results. It could be both situations, that if it's only the tabulated results missing and everything else it's fine, I assume that it would be good practice the applicant to be contacted and to be asked to provide the tabulated results or the full study report if it's available. It could be also the other situation when the study has many other deviations apart of only the full study, the tabulated results missing. So there might be a situation where the evaluator would decide that even if I have the tabulated results, still the study is insufficient, or the quality of the study is not good enough. So in this situation, they may conclude that we are going to assign in any way MTC tap of 0.1 microgram per liter, and they would not come back to you and ask for the tabulated results. So it would depend on the case. I just gave two possible examples how this could be tackled. I hope it's clear what I said.
The next one.
Yeah, and there's also the next one, indeed. The slides on toxicity data states that the information requirement for in vitro genotoxicity mutagenicity, section 611, must be covered by experimental studies in relevant chemical species, and it was explained that no read across is possible for genotoxicity endpoints. Is this understanding correct? Yes, it is a correct understanding, and I'll just, because I have the legal text in front of me, so I can cite, I think it's also cited on the slide that it was referred to in the question, but I can read once again what this part 2.2b states for this general adaptation. It says that the general rules for adaptation under section 1.3, qualitative or quantitative structure availability relationship, and 1.5, grouping of substances and read across approach of Annex 11 to REACH regulation, shall apply to the standard information and testing referred to table 1.611 only in the case of a substance constituent or a non-intentionally added species for which experimental testing is not technically possible. So this is what I tried also to explain in the demo, that for the applied for entry identified as a relevant chemical species, only experimental data, and this is what the legal text says. The reference here to REACH regulation is because it's used mutatis mutandis with the Drinking Water Directive. So we use directly the provisions there to our provisions. And I think I can also take this one.
My suggestion would be,
Yes.
we have run out of time, and because this person helpfully suggests to have a written rule, we can do this in writing on this one.
Okay.
Just
Okay.
to
Yes.
we use it as an excuse to not to prolong this for too long. But yeah, as I mentioned before, written responses to all questions will be provided. So if that is okay, we're gonna take this away about the numbers, and we'll come back. And the last two, I think they're for me. Now, for a complex alloy, we need to upload the risk assessment for all elements, constituents, and impurities. You need to, assuming that you mean about section 8 of Euclid, you need to provide documents, records for each one of the relevant chemical species. I mentioned before my typical example of the last couple of days, silicon, if it exists in your alloy, but it is an impurity, silicon is not a relevant chemical species. You don't test it in for migration, don't do anything about it. You need to provide in section 1.2 in the composition, the chemical composition of your alloy, but you don't need to test it for migration, and you don't need a document, a record for it in section 8 of Euclid. But for all relevant chemical species, yes, for the copper and the zinc and the aluminum and the lead or whatever is a relevant chemical species needs a document. The justification for the allocation factor, as I mentioned, you need to go into section 6.4 of volume 2 of our guidance, which is being updated, and it will be released in updated form, especially this section and a few other sections, but this especially section 6.4 in July. Please take a look there. Very briefly, for metallic compositions, the standard allocation factor is 50%. Only in a few cases where you can show that the metallic composition, the metallic products in contact with drinking water constitute the only major source of contamination, or where the toxicological value is substantially high, as it happens in the case of copper or zinc, then you may justify a 90%, but your standard percentage is 50 for metallic compositions, to be clear. 90, we saw the example of zinc. It has a very high parametric value, SML value, so you can use 90%. But please, section 6.4 of volume 2 of the guidance. And finally, this comment, I suspect it refers to, it says, in case an empty setup exists, the applicant should submit at least any new or updated information available as from the date of the Commission's decision. In which way has this information to be provided? This needs to be provided in the way that what we have shown the last couple of days is just information to be provided in your dossier. This is a reference from point 1.1 sub point B in section 1 of Annex 5 to Decision 365, which basically says, in the future, when the Commission has issued a decision on an application, so somebody makes an application for substance X, the Commission reaches a decision, says, yes, we agree to put it on the positive list, and the empty setup value is 10, 20, whatever it is. Later on, after that, if a second review application is to be submitted, somebody can rely on that empty setup value that the Commission has adopted, with the exception of any new or updated information which is available later, that became available later than the Commission decision. So you make a first review application in 2027, let's say 2028, the Commission decides, says, yes, let's put it on the list, keep it on the list, empty setup value is 10. Then in 2035, somebody wants to submit a new review application, then it is possible to rely on that empty setup value that the Commission approved, unless there is this new or updated information. Now, what happens then is, let's say you have a new, genotoxicity study that suddenly shows that the substance is genotoxic. You need to follow the advice that was presented by Vesela earlier today to provide information in section 7.1 of your Euclid dossier to explain that I have now new genotoxicity data. Here's the data. My conclusion is the substance is now genotoxic, which means the empty setup value of 10 that was approved by the Commission earlier is no longer accurate or appropriate, and my proposal is to have an empty setup value of 0.1. Now, this is just a scenario just to explain the thinking, but this requirement is for the future. After the Commission decision, the first application that has been received that involves this relevant chemical species, which has now a Commission-approved empty setup value. And I can see a last one just arrived. We'll take this last one and wrap up. What is the procedure if a drinking water directive application is rejected? What is the procedure if the applicant fails to answer the questions raised during the review time of a drinking water directive application? Does the new application have to start again from the notification of intention? Okay, let's unpack this. The procedure for rejecting an application, it depends when you mean. There is a possibility to reject the application, the accordance check, when you have a second failure. So we go through the accordance check, we send you communication to say you have failed because you things X, Y, and Z are not correct or they're missing, okay? And you are given a certain period of time, 6 months, for example, to improve against the information requirements, to come back and make another submission. If you make your submission within those 6 months, and again we find that you have failed to address the concerns we have raised, then the application is terminated and you need to go back to the beginning. You may also fail the deadline. We give you 6 months to submit a new dossier. It takes you longer. You miss the deadline. Again, the process is terminated. Okay, this is where I don't know, reject is not the correct term, but we are terminating the process there. Later on, let's say you pass through the accordance check, the application goes to the risk assessment committee. The risk assessment committee discusses their opinion, the scientific opinion on the application. They do have some questions for clarification, as you mentioned, and they send you the questions. For whatever reason, you are not able to respond to the questions. You miss the deadline, or you don't have the information, you don't know the answer, or whatever. There is no automatic penalty for this in the legal text to say if you don't answer, you fail. The committee will try to reach a conclusion on the basis of the available information. So to give another example, which of course it's an imaginary example, they ask you questions. What about, we're not clear about the joint toxicity conclusions in your application. Can you explain X, Y, and Z aspect? If you fail to do this, in the absence of this clarification, the committee may have no other option than reach a conservative perhaps conclusion that they cannot exclude joint toxicity, and they end up with an empty setup value of 0.1. But it's not a penalty because you didn't give us data 0.1. They need to look into what information is available, and they may end up with something very conservative or perhaps not very favorable to you, because this is the information they have. They ask for new information, new clarification. They didn't get it. They need to make the best out of it. Again, RAC does not reject applications. You may get a negative opinion, an opinion that says, in RAC's opinion, we should not add this substance in the positive list, or we should not renew it because the applicant has not demonstrated that the risks are acceptable. And then the opinion goes to the commission, and it's completely the commission's job, together with the comitology process, with representatives from the member states, to conclude we're going to put it on the list, keep it on the list, remove it from the list, change it on the list, or whatever the decision is going to be. So this rejection is not really perhaps well understood. There is termination at the accordance check if you have failed to meet the information requirements twice. And then later on, during the opinion-making process, you may get questions. If you fail to answer them, you run the risk of getting an outcome which is not favorable to you, but it's not that we stop the process and nothing happens. There is the theoretical possibility, of course, to withdraw from the application process. The right to withdraw applies only up to the point that ECHA sends to you the draft opinion. If the draft opinion has been sent to you, the process will continue even if you decide as an applicant to withdraw. But if before we send the draft opinion, after 2-3 months, let's say in the process of RAC developing their opinion, if you decide to withdraw for whatever reason, there is the possibility to withdraw. What happens there, very briefly, and you need to read Regulation 369, that an announcement will be made on our website to indicate that there is a withdrawal process ongoing, and there's a period of time specified in the legal text during which somebody may come and step up and agree with you to take over the application. So the application may continue with another applicant because somebody formally has handed over the application. So the application will continue, and the market obviously will be able to access the substance if the application is successful. But there is a possibility to withdraw, and if nobody shows up to take over the application, then it's terminated. Not rejected, it is terminated. Okay, that was the last question. Thank you for all the questions. We ran a little bit over time, but it was useful. I hope you find the event useful. We did not cover everything in Euclid. We covered a lot. There is a feedback form that you can access through the same Slido, QR code, or the event page. Please give us some feedback. Make it as detailed as possible. Something that was good or not so good, something that you enjoyed or something that were missing, something that was not clear or something that was clear. So next time at the next event, we will be able to address it in a different or better way. Also, if you think that there are specific topics that we should be covering and they are not covered, please let us know. That will be very important for us. And when the slides become available on the event webpage, please take the time to go through them. There are many links to many resources. If you are starting from scratch, from zero, there are places to start from. So it may not be the guidance document. Start from the infographic, go into the practical guide, understand the process. And if you have any questions, go please to the help desk. Ask any questions you need now. After the process starts, it will be more difficult. Good luck to those who are preparing applications. If you are planning to apply and you have not notified, consider the requirements. The notification has a validity of 12 months. Do it sooner rather than later. Yeah, we hope to have been of support to you, and we will continue to do our best to support all the applicants. Have a good afternoon, evening, where you are, and see you again soon.